you are doing well. We're gonna do surface nets today, or at least understand them. And I think I got the wrong mirror open. My bad. Is this actually oh my god, it's leading to the wrong mirror. It's okay. This one is the right
What
one.
are like surface nets? Why you use them?
What? Surface nets.
What are surface?
Yeah, that's what I'm gonna explain. So, if this thing would load, I hope this is loading the right mirror now. Jesus Christ. I think it's not doing it. I think it's loading still the wrong mirror. Damn it. I wanna draw on the right one, not the wrong one. Because it's taking so long to load. Yeah, this is the wrong one. Okay, this is the right one. God damn. Let me quickly just update this one to always take the right one and not... Wait, is that the same? Ah, okay. Well, I don't know why it opened the wrong for a while. But okay. Surface nets. So, we have been doing marching cubes. I still don't have the chat open. Sorry, guys. If somebody's saying something, I cannot even read what you're saying. There. Did somebody say something here in between? Let's see. Nobody said something. Okay, we're good. We're good. So, surface nets. We have been doing marching cubes. Surface nets are in a sense not exactly the same, but a bit similar. A bit better. And let's see, I was reading this part code example. I think you can add a code block, embedded iframe. Let's see, code block. I wanna which one is the where did it go? Oh, there. Okay, type something.
Wait, what? Since when? What?
Oh, there's always like plugins that you can tools, media, and integration.
Okay,
And you can. There's some of them cost. And so also, I woke up 10 minutes ago. Perfect timing. Shit. Okay.
Switch the language.
Yeah, this is actually C sharp. That will
C.
work. No, it's C sharp. But I guess you can do C. No, I don't know if it will accept it. Where is C sharp in this? Damn. They don't even have C. That's pretty.
Bro, you can't tell me they have fucking JSON, YAML, and Kotlin, Java, but SQL, but no fucking C sharp. Hello.
C++ probably the closest I can get to the
Hello.
syntax. Okay.
No Rust even?
What?
Okay, so let's see. I'm kind of reading this article. You guys just need to be caught up. This just is a pre-explanation about different approaches and whatnot.
Is that your code? I see
No.
6 for loops indented.
No, this is not mine, but I'm gonna make it.
Yeah, it's not mine, bro. I swear.
Yeah. Wait, can you guys hear me on the live stream? I think everything is set up correctly. Yeah, good. Oh my god. I've been away for 1 day, and Harold is already raping the soundboard.
Alright, play about sound.
Anyway, so this one this is still just a what this will do is it will iterate every single coordinate, right? This is still from a flat surface, but I think the idea would apply even for a spherical one. And then what it will do, check 8 neighbor voxels. And basically what that is just taking, well, we go through every single one of these, and then we should go through every single one that is like neighboring. So if you have a voxel like this, and then there's that beautiful, right? And then we have like vertices, right? On all of these, there's 8 vertices, right? And now
before how it works, like why even use it? Like what are the advantages or disadvantages?
The advantages of doing this is a possibility for me to get a more what's it called? I can get the thing I can do with this is I can utilize the positions more precisely for the navigation, and I will also get a more a precise terrain generation from this compared to the marching cubes. At least for my spherical, because I'm not making a 2-dimensional map. I'm using it's not it's not that I'm using a flat, like I don't have like in Minecraft where you have a flat terrain like this and then you walk and you do whatever. I have a sphere so you can walk like around and you need to be upright on every single one of these. Marching cubes works for the simplest ideas. But now when I want to make the enemy, I want to make a more rough terrain. Like this, and then maybe a cave that goes something like that or whatnot. This is a beautiful planet.
Interesting planet, yeah.
Yeah. And now I can no longer tell the enemy that it just needs to walk like get the force towards the player, because if the player is down here, it would be getting a force down into here. That wouldn't make any sense. And if the player was here, it doesn't make sense to get a force like this. It needs to get a force that walks around or up, right? And what this will allow me to do is that I can now
sideways.
I haven't looked that deep into it, but what I'm understanding is that I should be able to get a lot better idea of a position, because surface nets uses this as the identifier, the center of a voxel. And that means when I get a position, I can easily figure out how and where they are on these things. I can like round it down to a precise position, and then I can, based on that, I can do the navigation on how to get to the player. But I haven't gotten that deep yet. I'm still trying to figure this shit out. But that's like the vague idea that makes it why I want to use them, because they allow me for the navigation, and they allow me also to make a better terrain generator than marching cubes could. I think they also explain a little bit about it in this article here. For Minecraft, let's see. They had an explanation also about it in here. But Marching Cube itself. But if Marching Cube is so good, how come we did not pick it for over surfaceness? To be completely honest, looks, granted it sounds superficial, but if we weren't bothered with looks, we might as well just use height map and call it a day. Okay, yeah, that's also true. But height maps wouldn't work on a spherical thing that I'm trying to make. Or it would, but it would be a lot harder. It's easier when you have a flat terrain to do height maps. But yeah. Okay. And in here, we will go, so we get some position of a voxel, right? And then what we'll do is we'll go from... What is that rule? What does it do? It takes like int d is equal to x, so we get the same voxel position that we are at, and then we'll take as long as it's smaller than, so it will take like 1 plus from where we are at. So let's say we're at 0, 0, even though it starts from minus 1. So that means it will take for all of the x's until it reaches this one. So we'll go here. And then it will take, so we'll go from here to here, we'll check these two. And then it will also do it because we have the x, and then we have the y, and then we do the same in the z. So we have like positive in all directions, this. So we'll check all of those. And if a voxel exists, add 1 to our checksum. I'm a bit confused what that, like you do voxels new, and then you plus, if it exists, if you append, is that like a checksum voxels? Is it just like a normal array or something? I'm a bit confused about this. Can I, okay, I can do this. Good. So I can actually read what the fuck this line is. If a voxel exists, add 1 to our checksum. So if voxels new, so it adds it to their checksum. But what does that mean? Like, if it's true, does that return if it's true that it already existed, and some plus plus, and then here it just adds some. So if it already exists, it adds it to the sum, or it's at sum, and then the sum is only 0 or 8 if all checks blocks are the same. So either there isn't a single if a voxel exists, add 1 to our checksum. If a voxel exists, so if it already exists, this coordinate, this vertex, whatever, then it will add 1, and only if that feels wrong. Wait, I think I understand it's wrong, because if that's correct, then that means that modules 0 modulo 8 and 8 modulo 8 are not equal to 0. Or they are equal to 0. So then we can't add it. But otherwise, there is this coordinate, even though I think that should be a voxel, but it seems more like a vertex. Started to account for the fact that we only check neighbor and create mesh in the positive direction. Yeah, it should be vertices, but I don't know. It says check neighboring voxels, but I guess it's supposed to mean that a voxel is this position, even though it feels like vertices positions, but they are voxel positions. Weird. Okay, sure. Okay, then it makes sense, because that means that if there is a voxel or a position out there, so it only checks full and air, I guess. That's what it has to do. And then if there is a air block, then it would not... Then if there wouldn't be anything. And if there's a full voxel that is surrounded by only air, it wouldn't be added to the list of surface nets. Or if there is one that is fully surrounded by voxels, that one wouldn't either be added to the surface nets. That's a bit funny. Is that true? Let me check. I have a conversation ongoing here to understand this thing. Voxel center position is fully surrounded by air or solid. It won't be added to the surface net. I think mixed boundary add vertex. But isn't that vertex supposed to be a voxel? I'm so confused now. So only voxels that sit on the border between solid and air make it into surface nets. Interior solid voxel add open air voxel. Both ignored, you only care about the skin. Okay, now, okay. But is that surface net a voxel or vertex? I'm a bit confused about that. It's a vertex, but its position comes from a voxel position. What the fuck? The voxel is just the data. Solid air, Boolean grid, yeah. Oh, so that will be so the information comes from a voxel that transforms it into a vertex. So voxels are vertices. Okay, that's interesting to think about it like that. The vector tree key is the voxel grid coordinate, just an index, and the vector tree value is the actual vertex position in space. Wait, surface cube found add vertex, but then you add new. But those two are the same thing right now. So surface net is a collection of vertices. They happen to be positioned at voxel's center for now, but then you nudge them towards the actual surface. The voxel grid is...
What are you doing?
I'm trying to understand how surface nets works.
Okay.
Yes. The voxel grid itself... Wait, but they just happen to position at the voxel center for now, but later you nudge them towards the actual surface. The voxel grid itself is thrown away after extraction. The mesh only consists of those verses. Yeah, but that's the thing that I'm thinking I can reuse. Let me see. Use for...
What is a surface net?
Surface net is pretty much... It's an upgrade from marching cubes, except that marching cubes uses more or less the table to generate. This will be more... that's what I'm trying to figure out a little bit. Like, I understand that I can use these... This is the thing I'm struggling with now, is that... hello, Kyle. That the voxel here is both a vertex position for the mesh, but at the same time it's a vertex. And that's what I'm trying to figure out right now, because if I understand this correctly, is that I can reuse what will be the vertex position as the actual coordinate for that. So when I ask an AI or an enemy where you're at, I can figure exactly out where on the mesh they are, and I can figure out how they should navigate to the player. They will become both a mesh and nav mesh at the same time.
Yes. Yeah. As for nav mesh, I mean, obviously, like collision mesh and nav mesh maybe makes sense, I guess. But the problem is, like, I mean, yeah, that's fine, I guess.
Yeah.
But
that is the thing I can reuse for AI navigation. Fine.
because you're probably gonna have different amounts of tessellation, like different level of detail depending on where you are. So you are gonna store nav mesh regardless, even if it comes from the same data source, right?
Yeah, like they will definitely, like the vertices that I used for the mesh illustration won't be the same as they are used for the navigation, but they will still have to be somewhat similar. Or I'm still trying to figure this out a little bit about how to know how something should navigate. But I guess I'm kind of more interested first in the generation of the planet, to find out where the AI is at, so it can navigate to the next point towards the player.
Another big brain method that you can use is, instead of creating all this, you create a mesh. You have a mesh set, basically, your data set that already exists. Think of an icosphere or some bullshit, right? And then you just reposition the vertices to the nearest I guess you just basically kind of fit an already good mesh onto your new data, kind of.
Yeah, I mean, well, we'll see how this goes a little bit. I'm still reading about how surface nets works in general, and at the same time trying to merge this with my flow field idea. I stopped using AI, Kyle says in the chat. Why? Is exactly those vertices and the quad triangles connecting them are your nav mesh. For flow field, especially, each triangle is a node.
Triangle, a node?
Yeah, but now I'm thinking, because I'm not
flow
storing
field?
them as triangle, I'm storing them as nodes, I was thinking. But let's see, or as vertices. Shared edges between triangles, connections between nodes. You compute the flow field once from gold player outward through those connections. Well, actually, yeah, I guess it kind of makes sense. Each AI just looks up which triangle it stands in, reads the flow direction, moves. The nice thing is you get the nav mesh basically for free, since you already had to generate the mesh for rendering anyway. Same data, dual purpose. The only extra work is building the graph, which triangles are adjacent to which after a mesh generation. But that should be pretty straightforward when I get the...
I don't get why it's telling you to... Each triangle is a node? It means vertices, right? It means each vertex is a node.
Yeah, I was thinking first that each triangle should be a node, but then it told me later on that each vertex should be a node, and I was like, what? So now it's telling me...
that makes sense. Yeah, that's how the data is stored. That's what the data structure looks like of a graph, right? Or whatever. Right, like you have a list of points in space, right?
Yeah.
Then you have another set or whatever, a heap, whatever, that is edges, right? Which is just a reference to 2 different points, right?
Wait, let me put the...
Like, and so it makes sense that you know, each vertex would be a node. I don't. This is just being retarded. I don't know what a flow field is. If it means distance from.
flow field is, you know, you normally use A star for pathfinding for enemies.
For
Flow field is, if you think now, if you have thousands of enemies, right? It's very unoptimized to go through every enemy and do an A
turning it
star.
into a lookup instead of calculating the.
Yeah. So basically, what they do instead is from the player, you calculate like a flow, you know, flood fill. You know that, or Dijkstra.
Yeah, you're just calculating the distance.
Yeah.
Each vertex takes to.
So yeah, so then you only calculate from a player how far it's to get to it from some parts of cells, and then enemy just checks which cell am I in, and then it knows which cell I should move towards. It doesn't need to do any calculations. It just sees, I need to move to this cell, and then it does that. And then you only update that graph, right, if the player switch to a new cell, because otherwise that it will always be the same path, right? It doesn't matter. So that's a lot cheaper to do than A star for every single enemy.
Yeah, yeah, exactly. You can also just calculate. You can save. You're gonna have like insane space complexity, but like you can just save distance. What the shortest distance from every node is to every other node on each node.
Yeah, that too. But it's yeah, and that's basically what
I wonder how big that is.
Yeah. But it needs to know where to go, and that's you need to do the flow field for, so it just doesn't take the short distance from one node to another, because if it's in the wrong
have
direction.
A player position. You have a player position in memory, so you can say like, okay, what's the nearest node to the player position, and navigate to that.
Yeah, but it's also like it's not necessarily nearest. It won't necessarily be the right way to take to the player if there's a wall right in front of it or something like that.
Yeah, it depends on how sparse your nav mesh is. Yeah.
Yeah, but let's continue. In addition, I was waiting for every time to ask my next question. Delayed my development. That's some crazy delay. Yeah, no, I usually just let it think if it needs to think longer, and then I do some other things in the meantime. Also, you do not know where does information come from. You are not sure if it's hallucinating. Well, that is something I also find that when you read blogs online, you cannot know for sure. Always like Stack Overflow, that people can also tell you something that's not completely right for what you're trying to do. And it's usually taking those information from those sources anyways, so it's just the same thing, just an extra step in between. And it kind of combines stuff, which is nice, but also it can combine them in the wrong way, which is bad. But nonetheless, if you
also very good at convincing you it's right.
Sorry?
Also very good at convincing you it's right.
I think it's more good at convincing that you... Wait, did you say that you are right or that it is right?
It is right.
I find it the other way around. When I'm telling something, it's like, you're right. I was like, no, I'm not.
Yeah, it can be very sycophantic as well, but like, I mean, the fact of the matter is like you don't have a. I mean, if something doesn't have a source, then it is unreliable.
Yeah, definitely. I still like to. I kind of like to read both blog posts or something like that, and then I try to understand. I read a blog and I go like, now I don't really understand this part. This is what it means, and then why does it mean like that? And is there something better I could do? And these things, and then I ask for more sources, and I'm going back and forth. But I find it's really good to brainstorm with and trying to figure out how things works.
Yeah, sure.
Now I need to figure out like a little bit confused about the triangle and a node, because I thought that literally the voxel is a vertex, right? And then that would also be a node, but now it says that would also, it's triangle that's a node. And that's confusing.
Triangle and node are very likely to come up in the same sentence then, I guess.
Yeah. So yeah, that's a bit weird, but yeah. You can go with both, let's see. That's interesting, because then it depends also what would I prefer. I think I would prefer a triangle, because triangle I can easily find out what's the... Actually, I could also do that with a node. I was thinking about the normal from the surface. Each vertex in surface net's a node. Edge between connected vertices connections. Simpler, you already have a vertex list. Triangles node, dual graph. Each triangle centroid a node. Triangles sharing edge, connected nodes. More accurate for agent movement since agents occupy an area, not points. Well, I actually just need the easiest way to kind of figure out what's the position. I think that's vertices would be the best. For your case, vertex as node is probably fine and simpler. You already have the SurfNet vertex list. Just build connections between adjacent vertices and run your flow field on that. Overcomplicated earlier by bringing up the dual graph. Stick with vertices. No, but now I need to understand dual graph. What does it imply by that? Because it's
Doesn't mean anything. It's a language model, bro.
just a way of
I'm
representing.
sure you can find out.
Instead of vertices being nodes, the faces.
Oh, dual. Well, yeah, dual graph is you turn each face into a node, turn each node into a face, basically. That's what the dual graph
an
is.
edge. Ah, yeah.
So in the end, you're still processing. I mean, you can call it whatever you want, but it's still going to be nodes and edges. That's what a graph is. So.
No, yeah. So the dual graph, it's quite interesting. So yeah, you take two vertices to generate the connection nodes, and that's a dual graph. That's interesting. Okay, I didn't know.
Show you.
No, I get it. For your flow field, you honestly don't need it. Just use SurfNet's vertices directly as nodes. They're already connected by edge for you. It was something else that I spoke about. Not this one, a different conversation that I had. Randy spoke about if I wanted steep cliffs like 90-degree more surface that would not do. Because when I ask, it's kind of like, if you were to take that, would the vertices be better for us, flow field or triangle? Dual contouring, yes. SurfNet places one vertex per boundary voxel at the average of edge intersections. This gives you smooth results, but can't produce sharp features like 90-degree cliff or hard edges. Dual contouring also places one vertex per cell, but uses Hermite data, the gradient normal at each edge intersection. To solve for the optimal vertex position, this lets it snap vertices to corners that preserve sharp features. SurfNet is smooth, rounded, simpler to implement, can do 90-degree edges and cliffs, but harder to implement. That's not what I am concerned about. With caves and organic terrain, SurfNet is fine. If you wanted micro-style hard edges or sharp cliff, okay, no, actually I don't really need the sharp. Well, it's sharp to some extent, but I guess not really that. Okay. Let's see. Until a new, precise question pops up, I will continue reading this thing because I think I got it. Understood what I needed. Floating list of vertices describes our terrain surface. So that would be this thing now. Progress. Now we can loop through every one of those vertices substantially less than every possible position of the world and apply some math. Okay, I guess we can actually just try to do that first. So we'll actually go in. I don't know how Jolt will like me trying to do this thing actually. It's fine, it's fine. Jolt will probably not like it at all. But we'll fix it so Jolt will like it. Jolt will have to like it. Actually, I think it's smarter if I go to shared so I can put the SP. And we'll actually copy this and call it surface net planet Zig. Or let's call it planet2.sig because it's actually just, yeah. For now, that's fine. Don't need to worry about it too much. We have a logical and then a renderable, but logical, do we need it on the client side at all? I'm thinking at least a server will need to know kind of like for doing the logic about how to, for the enemies to navigate. But I don't know if the client need to know anything about these things. I think, well, to begin with, I don't think I need to care anyways about it. Let's see. Yeah, okay. So we'll start from here. Let's see. I'm just making sure that we have at least size 3. And then radius will, what do I do here? Clamp size. So I do half. But these ones now need to work with whole integers, I think. Let's see if that's the case. For surface nets, I need to work. I would do that otherwise, but I want to see if I can do float. Whole integers, right? Right, probably was unnecessary to ask there. Let's see. No, surface works with any float. Okay, but I meant more or less. I meant for the initial generation. No, still not necessary. What not? Okay, your density field can be okay. But how do I then put easier for the AI navigation to find which node it is at if we use integers so we can explore the position. Yes, like that's a good point. If you grid this integer as space, you can just do in from at for and instantly look up which node the agent is at with no search needed. Cheap with float spacing, you'd have to divide by voxel size first, which so it's not strictly required. I think I will go with integer just for that case. So we'll change this one. Size will be a u32, and then radius. Should I change the idea of a planet to be radius size is the thing you input, or I could divide it. Oh, no, I can do this. And then what we'll do is that we'll change this one to a U32. And then as we don't need to do an add as, instead we can do this, and we can just do, should remove the whole thing here. What? And then add as. Radius will be at divide truncate CAB, and we'll take numerator will be clamped size divided by 2. So now we have,
it worked. I can play.
and then
Crazy stuff.
points. How do they do this? They just, I don't even need to store this. I just need to store surface nets, and then
I heard so far they just have like a server list now.
Yeah, I know.
and then
I watch update videos.
Vector 3 int. What are these voxels? Are they like I mean, they must store every single one still though, but they don't. They just operate on the one surface nets. Oh, that was the thumbnail I was editing. Should I call them voxels as well? U32. Can I allocate and I make them like this? Would take 3. Then I could just do But that will not be enough. No, wait, will that be enough? Hold on, let me think. Fuck. Because then I will just keep an array of every single point that will be generated. And that would be... Oh yeah, but here actually what I do is just points just stores. It works a bit different now from before, but oh wait, but this is just I just need. Okay. If I get a 2 by 2 by 2, that yeah, I need to do it to the power of 2 so I can have all of the points stored. See if it already exists.
To the power of 2.
Yeah, I think this will actually take more space than I used to now. But actually, I don't need to. If a voxel exists, add 1 to our checksum. Okay, what are these voxels really supposed to mean? I need to check that. Array of all the voxels. How do I know? And does it check if it is a solid? Or what is this? If what is the if statement? If a voxel exists, add 1 to our checks, but then it has to just yeah, exactly. Voxels is just a dictionary hash map of bool where true, solid, not. Okay, so it just checks if that thing is. Okay, so that's what it means by exist. I mean, I would still consider a voxel as it exists, even though it's just air. It's still a voxel. Just means this is solid. So for each, evaluate density and then negatives. So the point evaluate density function at every grid point fill voxels, run surface nets, reads voxel outputs vertices, throw voxels away, only keep mesh. Well, that's the same idea, but I think we could instead just do a simple. I don't need to store these. For simplicity, I will not store them. I think I can ignore it. And what we'll do instead is that we'll create a function at evaluate and get rid of the marching cubes. See if we can get rid of all of these things. We will not need them anymore. Bye. I still need one of those. And then function. Did I remove one thing too many? Oh, this was still part of the actual. Oh my god, you're joking. Now please, why can I not just delete the thing? Oh my god. Like so. Boom. No. Like so. Well, this one doesn't need to be. So I'm gonna just function. Evaluate is solid, I will call it. Simple as that. And then we'll take in just a position of a 232 array. Yeah, that will be fine. And then we'll return a bool. And then if what we'll do is just ask if position I'm wondering, should I still do a I could do a self reference to at this if position shouldn't do a num c. I think I have access to num c. I would make it an vec. And set that vec 3. And let's just do that. Why am I getting such big problems with this thing? Where's my LSP at again? It's just cooked. Yeah, but that should still be fine to just... The LSP should still show up over here. It doesn't. Okay, great. 5th position. Actually, we can do end set, back, length, or distance is probably the right thing. Distance, position, and then self dot. Now don't store origin. Well, we don't need really. We'll just get distance to be a. We'll just do, because origin will always be this for now, so we can really simply do that. If distance is, we need a size then. Take it size. Position. Planet size or size. Yeah. But that should actually be half size, isn't it? Because if I do radius divide radius, I need to take in then, not size. Radius. And then if it's larger than radius, it will pretty much be the same thing that we do with marching cubes now, but just weirder. We don't need an if, we can just return, and then we want, if it's smaller, unused function parameter self, yeah. And I will return that. Sounds good. Okay, so we'll do this. We'll have the center, then we'll go through every single one of these like that. And they start actually from -1, which is quite interesting, I find. Or actually, let's start from 0 and go up. They start from -1. Is there a difference? Maybe I will change to -1, so keep the same as they are doing. Just do this, this is faster. Oh my god, if you do it right, it's faster. This one, and then we'll go here, and we'll do that, that. Yeah. And then we'll go up until we reach the size. And when we get up, we'll just do a simple, we'll not do this. All of this go bye-bye. I can just take this over to here, but so now I want to know, first of all, if does it have any, is any of its neighbors, but now I'll put it equal to -1, so now we'll access a -1 index, which is kind of funny, but that's okay. Yes, sure, I will go and ask every neighbor of it. Every neighbor. 4, and then we'll have a x. Well, it's less than or equal to, so x plus 1, like that. And I will capture delta x. It's a funny for loop. probably make that to a helper function. And this one will become for y until we reach y plus 1 called delta y. And this will set, and until we reach z plus 1, and we call it delta z, like so. And then we can also do that for some checksum, we'll call it. And we're not gonna do that, we're gonna call it, I don't think U8 should be enough, but I don't know if, what do we do with this U8? We just do, don't really use it for anything. And then in here, if, let's take it down, if, and now we wanna know, is solid. And then we're gonna pass in the effect dx, dy, dz, and then we're gonna pass in the radius, and if it is, checksum Zig, I'm not sure. Plus equals 1. All right. And then once we're done with the neighboring checks, if checksum modulo 8 is not equal to 0, so that means it's not a completely surrounded block, or it's not and it's not a completely isolated block either. Then we will add it to the surface nets, and these are the vertices that I will care about to generate the actual mesh. So that's basically, well, I guess we'll do the indices at the same time. We'll take these ones. Boom. So now we will have something that we can send over to whoever calls this. So then we can go vertices dot append. Should I append this? Append. Now we'll pass it GPA. Did I do the full size before, or did I actually do? I removed here. Let's see. Append, I passed in the GPA, yeah, so I never assumed capacity, I never knew how many I might have, so I guess we'll continue with the same thing. GPA. This depends now what kind of we have to do a switch on the kind. Yeah. Let's take what I used to do in here. We're gonna do the same thing, but slightly different though. We don't need that much. So we'll switch on the kind. We don't have to do this. So if it's just a logical, do this. We can probably position divided by 2. Don't need to do this either. I'll think about that. Else we'll have position, triad. Nah, I don't think we need this. The only thing I wanted to know was I don't even have. Okay, I don't even do the thing I thought I was doing. Okay, well, I do the normals here. And then here I do this thing appending. Okay, wait. Okay, let's do first the logical one. We care about the logical one. So we just want to get the position as before. I don't think I care about that actually. I'm not gonna care about this. So I'm just gonna say it's the pure position that we have been working with. And that's just X, Y, and Z. X, Y, and Z. Simple as that. That's the logical one. Let's just comment this out so we get the MLSP back. And I can't because I don't know, my new game is broke. Why? Let's see if you're in here. All right, we'll do one more, I guess. Why is it broken? Okay, it's okay. I will do it manually just to see that I get it right.
Fine, I will do it myself.
It should be something like this, but I don't know. I don't get any MLSP about it. Okay, so some indentation is very wrong here. Let's see. See, that should be. We have this one, which is for this. We have a switch. And we have the logical, yes. And then we need one more for the for loop. That's better. And these are just the vertices now. I did jump so far. And this just it's fine. And then if it's renderable, we'll do the other way, which is this thing now. Take it from here. Oh. Go there, and then we'll do a and then boom, 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 and damn, look at this amount of indentations. That's like a lot of them. You joking? So, and if it's a renderable, we will, let's see, the position still will be the same as we would do otherwise, but we can't really just the position. Let's do this position. Do that, and it will be of a. But we do append still a raw. Yeah. And that's for skinned. Yeah, this one will be skinned. So this is done. We don't need to do this. Then what we'll do is what is this for? We do a cross. The cross is used for the normal, which I don't think even is right. Oh wait, actually it is. I'm done. Yeah. So we can find all of these. Wait, hold on. Normals here anyway. What is the cross? I do calculate the normal. Yeah, the normals was fucked. Yeah, we don't need that. Okay, and then we don't use the len either, so we can take that away. That's crazy what I have done. Let's see. This is supposed to be, but if I don't need it, we can also remove it. And then we don't need to do this either. And then what I can do here, but this will not be enough for. It's okay. We just do this for the renderable planet now. Yeah, we'll do that. That's fine. So the vertices and position will be equal to a dot x, y, z, 1. will normalize based on the same idea. But we don't need to do that, actually. We can just do a x, y, z. And then UV colors. Should I worry about the colors? If yeah, this is basically asking if, let's just do red. So if x and then y, and then this one is set. Shouldn't even care about that. The UVs are fucked nonetheless, so doesn't really matter. We'll just add floor mod. I really don't care. We'll just say it's simple. We'll say x, don't need it for it. Say x, and this one will say y. It's not right, but it's just to have it there. And then indices, whoa, like so, and like so. Center position is never used. No, that's crazy. Because it's used outside. It's in here. Lol. Freaking hilarious. We can remove this, and let's just check this how it would work. I think we can do that. Let's still render the server with the same thing, but the client, I'm thinking we can change this logic. The server should not change this, because then it will be we won't even get the same run shit. Well, it's fine. I just want to see it visual. We don't even need to react with it the right way. Where is... I think this is actually done. That's funny. Let's see, because we do get a spawn, and then from here we do the spawning of the thing, and it is, we'll go in here and we'll go to root, and then we do have planets here, I assume. How else do we, how the fuck do we get the planet? Let's see. Oh no, I didn't mean to do that. Damn it. Okay, let's go to the top. I just say
Yo, Lucas, you got to look coding.
Moment. Planet. Planet 2. Funny enough. And then I say I want planet, but I don't see it here. Wait, no, here is planet. I'm dumb as fuck. 2 planet. Simple as that. Do you actually just call the whole thing? Is there a planet structure inside of the planet? We'll see how this goes. This will be funny.
If there would be a planet structure inside of the planet, it will not compile. But you see, while station stream. Yes.
And I will say planet 2.
Alright, planet 2.
Yeah. It's pretty fire. Alright, let's see how bad this goes. It didn't compile. And that's
yeah,
server.
so you can look in coding now, because you don't need to have this compiling anyway.
No. File not found.
Yes.
It didn't find the file planet 2, but it's in the same place
Bro,
as planet 1.
Trust me, it's a really cool thing is in the coding channel.
No. What is this?
Okay, so basically this is WebAssembly. Actually, I'll stream my screen, bro. Trust me, this could actually be useful for you if you wanted like some modding or something. I don't know.
Well, that's too far in the future. I think it's right now. It's not really something I would directly like to spend time on because it's not something I will directly work with right now.
No, you don't have to spend time on it. You just have to look at it. For
No,
2
but that's the
seconds.
thing. I'm spending time on the wrong thing if I do it.
Well, you hear me out. You're spending time on a lot of other things.
Yeah, talking with you, so let's not talk right now. No, but for real, I really want to get this thing. So let's see. Import planet. It is called planet. Oh, I called it with capital P. Can I still do call it? Capital P. Okay. Now we'll run the client. Let's see what happens. It doesn't happen. All right, that's okay.
Anyways, guys, I gotta go. I don't know. See you in 6-7 years. So.
All right, take care.
All
Take care. How can I put a negative value in that? Thought I.
You say minus and then the value.
Yeah, it doesn't like it. I didn't. This is new for me. All right, good. Let's learn. Let's ask.
What was? Minus. Oh,
Yeah.
yeah, that's good.
That's weird.
Yeah, you see, you just use C for loops.
That would work. Let's see. Now we're unlocking the new Zig range are always used as they can't go negative. Use a while. Oh. So if I want to use a negative, I would have to go. Oh God, no. And I would have to do an int cast. That's funny. Can I declare a for loop like in C instead? Because that would be way more convenient right now than doing this. No, Zig has no. Okay, goddamn. So I actually would have to.
Wait, I thought you can do for loops like in C and Zig.
No, that's okay.
You really can't?
No.
No.
I will have to write C for loop in another file using C, and then I can do this. That would be so cooked. That's okay. But then I cannot capture the same way. I would just do a that's fine.
Oh, Lucas, this code. I love this.
Oh yeah, the indentation.
4.
Don't worry about it, okay? We'll call it var x u60 i64 i32 is probably good enough. I'm not gonna go that big. -1, and then like it said, we'll change these to become. We can change all of them actually.
You have in the if you have 9 levels of indentation.
Yeah. We'll change this to a while. Like so. And then what we can do is that we'll take this and we'll ask while x is less than. You want equal to clamp size? No, clamp size. Like so. And then I think it was. Did you do? Is it like this? And then you do x plus equals 1. Was that supposed to be the capture? How was the syntax for this? You need a colon in between, okay. But now I have x on all of this, which is not good. What? That's not what I meant. Wait, that's what I meant. Oh my god. And then I will do that, and I will say y, and then I need to declare y, because y doesn't exist right now. Y, u, y. And then we can yank that, and we'll paste it here, and we can do that, and we'll say set, and then we can go here, and we can do this, and we can do that, and call it set. Boom. Okay. And probably this for loop will now be fucked as well, because you can still start from negative value. So this one also needs to become wild. It's funny. While, and then we'll go from x or that to until we are this. But I think this one wanted the equal sign. Yeah. Otherwise, it's the same idea. That's cursed, but that's fire. Okay, let's see if it breaks or not. It did break, and it breaks because expected. While is does it need a parenthesis here? What is expected? An optional type found bool. But now, yeah, I need. Can I not expected? Can I not capture that as a? Do I need to do a new dx as well, or isn't this okay? Do I have to declare also dx and dy separately? Why can I not just use them? While capture only works condition is an optional or an error union. Okay, unwraps the payload. Your condition is a bool, so there's nothing to capture. Okay, but the step your optional was for that range of length 1, so dx always those 3 inner loops do nothing. But no, I start from minus.
Here.
Yeah, I start from here, but I started from -1, so why would it just say that it's I don't need to change them? I think I do need to change those to whiles. Yeah, your starts is on the outer loops. That's preserved. The inner loops separates. Do you think I see your real intent now? This is a Martin cube surface net style, where each cell samples its 8 corners and checks some counts how many are solid. For that you need range, not +1. But I think it still misunderstands that I start from -1, not 0. Or am I dumb? Right, and the inner loop is that. What? Copies the current value of x, so it will be a -1. So I cannot do a. What does it say now that? Wait, hold on. You need range, not, but then it's just still. I think it's lying to me, this thing now. Well, maybe it's right. Maybe I'm just stupid as fuck. We can still do this then, I guess. And then we'll change this to dx fx, great. And why am I pressing the wrong buttons? dy, fy, dy, and dz. And it will become equal to, wait, hold on.
Hold on.
Y, z. And then in here we'll change this to increase the delta movement. Actually, I think it's cheap, smarter if I do that, and we do like this, boom, 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 and then we'll do a colon, comma, or parentheses, plus equals 1, and then we'll put a one of those, and boom, shit. Now let's see how bad this goes. Expects type. Why did I? I'm just used to doing a 32. Okay, expected an tree around LA found 4. Do I not do positions as... Oh, actually do them as a vector. Interesting. I forgot. Expected type vector is found. Have to do an int cast for every single one of those. Ain't no way. Let's see. Do I need to do component wise casting? Or is there just like casting the whole structure of, because they are still just vectors? Yes, oh shit. Well, thank God it just gave me the thing because I didn't want to type those out. Not that it would have taken that long, but I didn't want to do it. And I still have to change them back probably later on. Let's see. Square root not implement for sign. Where did that square root come from? Divide truncate. Plan to normalize. So when I do a normalize on this kind of position, which my LSP doesn't work. Great. Let's see. Well, that shouldn't be a problem.
Lucas, I want to see you writing C sometime soon.
I may be
Like,
doing
just for
that
fun.
maybe at the end of summer vacation when school starts again. I'm planning to do that then.
Oh, right, because you're doing C in school now.
Yeah, no, but also because that's if Planetary Sigma doesn't go too good, then that's when I kind of decide that I need to move on to the next project at that point. That's like my deadline, kind of. No, just the thing I just need to prove enough for it to work, kind of. Well, I'll probably continue on with it, but I just need to. At that point, I'm kind of like also aiming more towards getting a job, so I will just want to improve actual like skills that is hireable or something like that, you know. Signed must be of type vector array and not type of struct. But it's, let's see, division with comp time int and either the signed integer must use div trunc div. Yeah, because I've always been using F32. This one is a similar problem actually, if you think about it. Yeah, that's true. So what we could do is actually just take it out so we can reuse it. Do a const position, which will be problematic. And set back. We'll do a F32 3. So, and then we can say position is equal to position. And then we can pass position in here instead. Wrong button. buttons. And then we have, what is the next problem? Type does not support indexing. What? That should be completely fine to do. Unless if I do need to parentheses per every single one of those as well. But then I should get a compiling error already, or a build error here in the editor, but I do not. I do not. It's okay. Let's go back, put one here. Oh shit, no, fucked up. After statement. What the fuck happened here? Did I start another one? Let's see, I closed that. Oh, but I didn't start this one. I start this one and then I don't post. No, I didn't add. Did I add? This is for that, then that is for this. Oh wait, I do have one too many. What's going on? This starts it, this ends that one is for. No, this is wrong. This is so wrong. It shouldn't be like this. It is like this. I know it's like this. Why does it send it? Then I can't do that. And did I still forget one? No, this is right. Shut the fuck up already. No, it's right. Yeah, this is bullshit. I don't know why it's complaining about that. Because I think I should be able to do it like that. Type of does not support indexing. I'm just trying to create an array of those. Why can I not do it that? Like, syntax in Zig, the array goes before the type. Oh, okay, so I just have this. Yeah, I actually forgot that. Nah, bruh. So I thought it was the way I initialized the value was problematic. Expected type flow found U32. Fuck. Let's do a. God, now it went wrong. Order position, then we can do this, and then 0 and 1, just easy. Yes. And then incompatible types, struct, comtime, and U32. Right. And that one is also wrong. Maybe now it will understand. Or do I still have to clear it outside? Not implemented, signed. Because I do this solid. Okay. Same problem. I shouldn't do it like that. I should take an F32. It's okay. But I would have to do a floating cast as well. I would rather do it like this, just it's there. And then we'll do is this. Hold on. What the fuck? Why did it go all the way over there? Okay, now I'm just gonna type it. Jesus. We'll do that, and what we'll do is we'll go here and put a D in front of it. And then we'll go to there, and that's almost right now. We just need to change this position. Nano LSP. So. And radius unexpected type F35 with U32. That one will also have to become an F32, which means we'll also have to change it up here when we do, because we do want everything in float. I could do it down here. I just realized it would have been way cleaner, maybe. I don't know. We'll do it here now. Okay, it launched. Let's see, how does the planet look like? Does it crash or does it actually load a planet? It seems like it crashed. I am not getting any, or is it loading forever? Something is not incrementing. Timed out. Terminate. Let's take a look. Let's take a look. We increment all of these. This will start from a negative value, go towards a positive at some point. But now this, what the fuck? How are we supposed to ever reach the value? Wait, no, because I'm incrementing dx. Yeah, no, it's fine. And then when I go in here, I will put it to this, and then while that is that, I will just take the next one. It should be fine. cd log debug no lsp pause, and I will provide the position. Oh no, the any position. Any Zig compile struct. Let's see where it gets stuck. Does it get stuck here? Then it would stop, or then would we continue doing that? And if I connect, yeah, it just goes up on that set here, and that's, oh, that makes sense. That's taking a long while to, right, because it's the size of 100. There's the planet. It's fucked. And the new planet ain't looking too good. I'm just saying. What the fuck? Let's maybe not randomize the planet yet. That let's make it smaller. We'll go in here. We go to source, systems, and spawner. And then when I get to spawn, start stage, spawn planet, we'll just do this. And we'll just go in here and do a, let's do just a planet size of 4. How about that? Always run a planet size of 4. Right, that's so small that I actually get teleported out. Maybe not 4. Let's do 8. I could actually, wouldn't even have to restart. I could just hot reload it, or I do hot reload it, but I would have to start a new planet. So defeating the boss would take some time. But let's see how big is 8. 8 is barely enough for not being eaten out. But yeah. Hmm. Yeah, that's not quite right, is it? I think we did a reverse also. Let's see. Before I did SD mem reverse indices. Do I need to do that also on this one before we do the return? Save it. And this won't actually outflow the generation. I need to reconnect if I want to see it. Or I could just call the server to spawn a new planet. That could also work. Doesn't quite look right still. And that's funny. But this should only do the... I think I know what I need to do. Go to the Vulkan. Can I not open Vulkan? I guess I'm not in. Oh shit. That's true. Wait. Let's put this one over here. It's easier to know what I'm dealing with. Vulkan. And then we'll close that. We'll go down to the bottom. Almost it's pretty much on the bottom. And when we render the planet, it's a statical mesh draw static. So it's here. We can still do it for all of the things. It doesn't really matter. I think we will still be able to see. This is what I'm interested in here. If we'll say true, so or that, so we'll always take this path. Now I think we can do polygon mode point. Let's see, I think that will show us the points of it. That's all I care about right now. It should just show me the points. Well, yeah, we got points on all of the things. It's mainly the planet that I'm interested in. Yeah. And then what we'll do... I'm gonna go to emit mode node. Do I know anything about... I just know the mesh. I do not know the entity type. Damn. That's not convenient at all. And I do not know the entity here either. I only know the entity at what level? Reference. Well, actually, I could just ignore. I can draw static. And then here if entity find is not equal to planet. Start planet. Continue. We will not draw that thing. So now static meshes should be gone. That's items mainly. Yep. And then, well, we can just put the same thing in here and we'll not see that. Like so. So now we should only see the planet points, which we cannot even see at all. Well, okay, the UI is still drawing points, but that's, don't really care about that. Small problem. Okay. Let's see, is this one affecting the size of the planet vertices points? I cannot see the points. Well, I guess there's something, but it's not good enough to tell me shit. Ah, that's beautiful. Okay. PK command set. Is there point size set? Checkpoint set. Maybe if I could just do I need a debug mode to draw points? Is point not enough? We could also just do line. Look at that. It's pretty fucked. Let's not do that. The planet in general is just like I don't think it's supposed to look like that. Let's actually launch it through the snapshot on that, load it in. And let's see, assume this is the planet. I'm not, this does not really look right at all. Maybe it's, well, I'm supposed to just have the points. Actually, yeah, I'm just supposed to have the points. Let me try one more time with the true or that, and then we'll change this to point. So save that, go back to here. Yes, that's fine. And if I do this, and I'll take another snapshot, open this one instead. Let's see. Does this one show? No, it's still the same thing. It's just that it's supposed to be. I feel like I think I still got the right thing, but maybe I'm just. I got the right thing going on. It looks wrong. Because it's like. Well, these are still net. These are just the points, but I feel like I'm still doing. What am I still doing wrong here? Because it's kind of like not going. While it's. That should be right. Let's do this. We can do this just to see this work a little bit faster. Also hot reloading a bit better. We go to the player. Player controller, and if where's my debug thingy? Here, if you press K, yeah, we'll use this. This is kind of what I like to use for debugging. K is my debug key. What we'll do is this. We'll just basically restart everything. We'll start a new planet, and this should hot load a new logic for that stage as well. So if I change the logic on how to generate the planet, it should still work the same way. Let's see, we'll do that. And what I'm thinking is, I want to actually just see the prints that, I think I do see the prints already. It should print the position of the delta. The delta should always start from a -1 already to begin with. Shouldn't it? Let's see. And it, well, it does start from a -1. So why the hell do I not have it the right way? And I have yeah, that's right. That's how it should be. But it's not working. Something's very wrong. I think it's something is right. Well, I don't know for sure. Maybe I should just push on and see what happens. Maybe that's the better approach. I mean, at least we got some pretty decent logic to try things out. I think that's good. I think we'll do that. We'll do that. What the fuck is my phone saying now? Okie dokie. Now, yeah, if its position seems to be alright, checksum seems to be fine. I will just not do the reverse though. Let's not do that. And what will we do instead? We'll continue on with this thing over here now. Where'd it go? Oh wait. Did I close the page? That's fire. Actually, what the fuck? I actually closed the page, what the fuck? And this one is also pretty good. Alright. Yeah, I kind of got that. Not really though. Wait a minute. I think I know why. Hold on. Because this shouldn't... I start radius, clamped size. Oh. Right. I actually shouldn't start from... I should start from minus clamp size. Oops. Kind of forgot that. That's okay. Wrong button. Boom, boom, boom. And then we'll go back one step because my planet is on. That's okay. So that should hot reload it, and I'll still have it running here. And if I press K, it should restart and spawn a new planet with the new logic. I don't know if it looks any better or worse, but I would assume so. Let's take a snapshot and do it. And let's open up that. Still 58, so that means it didn't take the effect that I thought it would. Still does only half of the planet. Let me run it here. Oh, well, no wonder it couldn't take it because it didn't work. U32. What? This is IS32. What the fuck? What is he talking about? Wait, hold on. Negation of type U32. Yeah. Is that like illegal? Because I need to start from that and then go up. I'm starting right now, not at that. Okay, so can I just should I do an incast earlier, or is there like a beautiful way that I don't know about that? What I'm thinking I would do is probably just do a incast when I can't negate. Yeah, I'm not doing that though. I'd rather not. I will instead do this. I32 this. So, but why doesn't it complain? Like, why do I have to go like this to see that it should complain already? It shouldn't have to. Why doesn't it build on save? It's weird. Expected type either found U32. Yeah, this one I could do at as or intcast, I think. Doesn't build on save by itself. Something. No. There's a feature. LSP. You can look into that while I fix this and then. I think an int cache would be enough. My LSP is also dead. Now that's fire. Oh shit. Yeah, I have no LSP. That's great. It's okay. Am I actually in the right folder? Yeah, I am in the right folder. It says on save, it's off by default on your settings config or editor setting. Let's see. Well, user found I32. Radius, well, I can change that to I32. That's fine. And then I can also get rid of this thing over here. Let's see, expected F32. Oh fuck, no, that was not what I could have done. Damn it. Okay, there, boom. And again, move. That's fire. I don't really care. I do need to do only in here. So if I press K, it should start a new planet. And it looks like we got more vertices now. So if I now do a capture, we'll load this thing. I'm looking. Yeah, 227. That's yeah. Well, I mean, it's maybe. It's not supposed to be like an actual mesh yet. It's just supposed to have all of the vertices for the thing that we want to do. And I think it does that. It's really hard to see. But I think it's there. That's fine. Like, I think we have all the points. The points are there. These are just supposed to be points. So, I think it's fine. Because there's no points in... Well, it's really hard to see with this thing. Ugh. Can I just can I visualize it differently? Can I just put points here? Is that possible? Camera setting controls. That's just the camera. Damn. What is this? Nothing. Oh, no. Nah. But I think all of these are just... I think it's fine. We'll go with that. It is fine. Yeah, I think that's what we'll do. And I will continue with this thing. Okay. Okay, so now we can look through every one of those vertices substantially less than every possible position of the world. Well, I guess that's what we still did in the beginning to check if it was a... But whatever. The naive approach is to simply average all the adjacent vertices current position and move the current vertex towards the position. So, but wait, why is it? They just do it and it just works. But I still need to know who's adjacent. What they do just now is just works. Well, I guess they're using Unity, so they wouldn't have to worry about these things. But still, what the fuck? So linear interpolation between those approach is to simply average all adjacent vertices current position and move the current vertex towards the position. So basically just the linear interpolation between 2 points. Then repeat the process with the new positions as often as you like, and voila. Will this even work with a spherical idea? Because now it's that they do it on a 2D surface, like a flat surface, not a circle. But I think it should, like, shouldn't there be a big difference between that? You can imagine just this being a big overhang on the whole thing. It's just a more sophisticated approach. Yeah, this is more what I have. Sources, that's it. Surface nets generating smooth models from binary segment data. Pressing smooth high surfaces with flats from binary grids, smooth voxel terrain, surface nets in JavaScript, nil orbital voxel smoothing engine.
So how is it already 17 o'clock? Wow.
Hmm. Because I don't think I can just. I should really be able to just drop points, but I think the points should have been. Wait, can I draw points? A sphere, but then I would have to go through every vertex. I guess you could extract that data. Do you have the vertex buffer? And I could figure out how I should kind of like debug, but what would I draw? Just could draw a cube. Could draw a cube, yeah. I could do that. Even though I think that is pretty accurate. There's no point that it is inside of the thing. I do have on the surfaces. Not that many on this. Like, I guess it's not that deep yet, so yeah, it makes sense. But how do I draw the actual... Wait, okay, now I'm confused. Because if... Okay, I should probably ask the ZLS about from this one, because this one I'm trying to understand the whole concept of surface nets, and now it's working on my damn ZLS to get it to work. Alright, I didn't have save on build on this one. That's bad. Okay. Okay, so I got the for surface nets. It says let's provide thing less than every possible position. The new approach is to simply average all adjacent vertices, current position, and move the current vertex towards that. What does that mean? Move the current. The new approach is to simply average all adjacent vertices, current position, and move the current vertex towards that position. So basically just linear interpolation between those points, then repeat process with the new positions as often as you like, and voila. But I think that will just end up with the same mesh I have, maybe just a bit smaller. But my mesh does not align the indices well with the vertices. It's just me or it's yes, it's did, and it's for good reason. Unless we have an infinite time and infinite terrain, the average position of the voxels will converge in the center of the mesh. This effect is stronger and closer to a voxel is to the border, and the more iterations we do. And there are more problems. Firstly, we had cases where the mesh would fold in on itself after too many iterations. And the second was a problem where the terrain was turning too smooth after the first few iterations. The first problem is a bit tricky, but Sarah F. Frisk and Gibson already had this problem back in 1999 and described the solution to it in her paper. To remain faithful to the original segmentation, a constraint is applied, keeps each node inside its original surface cube. Right, the real problem you're not generating connectivity at all. Indices append, it just emits 0, 1, 2, 3, 4, 4. So your triangles are random consecutive vertices. That's why nothing lines up, yeah. But I thought that no, don't do that.
No.
Because that's what I thought was that it wasn't supposed to. They were supposed to be used as indices, but I think I could still use them to represent. Well, I guess no, I can't. Surface net is 2 passes, 1 vertex per. Wait. So your triangles are random consecutive vertices. That's why nothing lines up. Surface nets is 2 passes, 1 vertex per surface crossing cell. Yes, and you remember which cell owns which vertex index a map. Yeah, I don't store them as maps, I just add them. Aha! Whoops. For each crossing edge, connect the 4. For each crossing edge, connect the 4 cells that share it into a quad, looking their vertices up in the map. But then, how would I have to brutally go ask like this, and then when it doesn't, then I would just stop pursuing that path, or let's see. So cell coordinate, vertex index, cell index. So on hash map, where you store the coordinate, and then U32 cell index, and then the 30 in it. 1 vertex per cell whose 8 corners. What did it suggest even? Solid 4, 0 to CX for CY, cell X and cell Y, cell Z. If corner solid, at as iter to int cast corner solid. Solid plus 1. If solid 0 or solid is equal to 8, continue. Okay, and then else, but this is basically the same check that I'm doing already, but it's just doing. But you cannot. If you ask this all the time, you will be doing it for the same position, won't you? Wait, let me see. No, because they plus, okay, to the X. They do it like that. Okay. I mean, I guess you could do that. Instead of doing. Yeah, so then you could do a for loop instead of having a while. Whichever is cleaner, but it's the same thing. Hello, Ankylosaurus. I guess you could do that. I guess it would look cleaner than doing whatever the fuck I'm doing. It's a pretty good suggestion. Probably should do it. But then again, you get all of this ugly as an int casting in here, which is again not. I don't know if it really makes it worse or better, I guess. Then that's pretty much the same logic as I already do, but except that it just checksum is solid. And then it suggests to, instead of doing const index int cast versus item len, try cell index put. So storing the index of the vertex. Okay. So then we would just store. That's quite interesting to then have a way to reference it by key. Why do we do key to get the index? But okay. Naive cell and center relax towards corner crossing average later. So const position. You take the actual position and put 0.5. So this is now for more of the rendering. Okay. But how did it suggest to do the pass 2 for each cross edge? Stitch the 4 cells around it into a quad. What? Okay, so per axis the edge far corner offset, then edge 4 corner offset, then the 4 cells offsets sharing. Const axis structs. So you do a struct and then you have a B, either do and cells. That's Y. You get an X1, Y1, and Z. That's interesting. Now we're almost back on the tables, and then you have cell 0, 0. Okay. Oh, these are just like relative. And then you would do another for loop on a clamp side. And then while clamp saw is that, and then for each axis, okay.
And Lucas, the weather you have is so perfect.
The way I have what?
Or it's so hot. The weather you have.
The weather. What do you have? It's like raining.
Yeah, but I mean like temperature wise. Like I'm sweating my ass off here.
Yeah, me too.
What do you mean? It's like 20 degrees for you.
Yeah, that's hot as fuck.
Bro, we had 40 degrees like 3 days ago.
Yeah, that's like dead. Why are you alive still?
I slept like underground today. Like I didn't sleep in my room because it was
Const S0 corner solid. I wonder if this one is now trying take me a bit further than I need to go, because I don't think I need. Do I need? I don't like when it's just naming like this. I'm like, what the fuck is that supposed to mean? 0 solid 1. Corner solid, yeah, I guess. And if there are no surface crossing on this edge, but I think it's still wrong. We still got the information that we needed here when we were doing a thing. Why would we have to do a second iteration now with I think have cell through 4 cells, and then we get the index, and then have a cell, and then we have a V that comes from vertex. Hello Hypex GG. And then cell index get, and then C, which was the thing that we get from the cells. Jesus Christ. I think it's doing it more complicated than it needs to. I don't think that's a good idea. I think it's a bad idea what it's suggesting. But I still need a way to think it through. Like, if I got all of these, I do know which point. I just need to be able to connect them. That's kind of. I got all of the solid points. That's why marching cube was maybe a bit better, but no. We need surface nets. I'm pretty sure we do, but I need to think a little bit about. I do need to store the actual positions as well. I guess right now the vertices positions is the actual positions, but there should actually be a second map that I store them in that I would then use to. But that's not really needed for renderable. It's only for the logic call that I need this map. But I need it for the. I could also just try something funny. But how would I know which way? Let me ask it a little bit. I'm thinking. Wait. You are complicating it. Also, you use ambiguous naming for reference. Useful name. Oh my god. Useful name. But for the AI nav mesh, do not. How does no, how does this come together? Like, if we are on node 231, just random, how does it know how does the enemy know how to navigate to the next node? How does it know what is the next? Okay, enable. Because I'm a bit unsure about that, because I'm thinking this is still a bit in the wrong direction. Feels like it. Maybe it's because it's using such ambiguous names like A and S0 and S1. I'm like, what the fuck? You're right on both. Let me drop the mesh code argument and answer the nav mesh question. That's the actual thing, and how the nav mesh comes together. The key idea from your own design nodes, adjacency is free because every surface vertex lives in a cell at integer coords. The node is the cell coordinate. Yes. But how the fuck do we get a mesh out of that then? A node, but it's a node like the center of the, or is that also like kind of like an actual vertex? Because I'm feeling like that's not what we're doing right now. Server cell, the x0z integer chord where you placed a vertex. You already have the cell vertex. You already have cell vertex index. Yeah? Map from meshing. That I do. The same map is your graph lookup, yeah? Neighbor of, but then I should just store the neighbors then when I start, because from the neighbors I should be able to conclude how to draw the damn face, the triangle. If I just store the neighbors when I'm going through, that there shouldn't be more complication than that. Neighbors of node 321, the adjacent cells that also have surface vertex. Adjacent cells that also have a surface vertex. You don't store edges separately, you probe the 6-axis neighbors and keep whichever exists in the map. But now you have a bit of more, what the fuck? How many, quick, if you do a, yeah, so a vertex could, in theory, have or actually it should have. I'm probably not gonna be. Yeah. Vertex will probably have more than 3 connections, so can't use that as a just, yeah, it will always just be 3, bro. It can have as many as possible, so we actually need to do the edges, I guess, or then the triangles would be better in that sense. Would it? Or what if when I do the points, I would count them as
Ja, du bist so edging.
edging?
Mhm.
What do you mean?
Okay, also edging.
Okay. Or then do the because this could make sense then when you look up where the enemy is at, and you could just navigate to that triangle. For each cell index Get neighbor. If it returns a vertex, it's a walkable neighbor. Use 18 or 16 neighbors if you want. Diagonal movement, that's the whole adjacency query, no separate. Okay, but in that case, be better as node. So only, because a triangle should always, I think it should always have, it can only have 3 neighbors. There's no way I can add I wouldn't do this, because then that means that this would have to be a vertex here. So that would have to be a neighbor as well. And you can only have 3 neighbors. Yeah. But in that case, a triangle would be better as a node, so we can only have 3 neighbors per node. And then storing that, but then I would have to, but I think that would also be better for the actual mesh generation. To skip to fixed degree is nice, but degree isn't what cost you. What? No, that, what are we talking about? Node count and adjacency build cost are. And on surface nets mesh, triangles as nodes lose on both. Surface nets gives 2 triangles per cell. Does it? I don't see it from this approach at all that it would be doing that. If I have 1 cell here, I'll get 1 triangle there, I get another one there, I get 1 from here, I get another one here, I do get 1, like I get more than 2 triangles from 1, but okay, let's see. Yes, 2 triangles per cell, so triangles as node, 2 more nodes than cells as nodes, not fewer. The adjacency isn't free, you'd need this edge triangle map to find its neighbors. The cell map you already have is adjacent for free. Probe the 6 neighbor chords. What? Oh yeah, but wait, actually I only do have the possibility for how many neighbors? 8. Or, well, 7 I guess, because if you have 8 then basically you're not valid anymore. Breadth first flow field cost doesn't care of the read. Triangle mesh reacts detour style wins when you have. If I do vertex node as vertex as node, I can only max have 8 vertices as neighbor max because of voxel, right? And if I do have 8, then I should not render and be a surface at that.
Cheesecake dodds the bug.
Missing
We're
the
done.
the 2 different 8s. The 8's corner of 1 cell, that's the scalar field sample used only to decide whether a vertex exists. If all 8 corners are solid, 8 count fully inside, no surface corners, no vertex. If still fully outside, no vertex. Only mixed 1 to 7 cells get vertex. That's your solid. Yeah, but the neighbors, those corners, how can that be? Because if I cannot be a neighbor of anything if I do not exist. Surface net vertex lives on 1 per cell. But 1 per cell that exists, it should be, because a cell that's not, I don't get it. Its neighbors are the adjacent cells that also hold vertex. 6 face adjacent cells. The usual choice up to 18 if you add edge adjacent. up to 26 if you add corner adjacent. So max neighbors is 6 or 26, never 8. The 8 is corner neighbor cells. If you have 8, then I shouldn't render it. Right idea, wrong number. If all 8 corners are solid, you don't emit a vertex, but that's the render exists test. Completely separated from how many neighbors the vertex has, and render surface vertex can still have anywhere from 0 to 6 cell neighbors. How is that possible? So node cell max 6 neighbors corners the 8 samples that decide if the node exists. Two different. I don't think so. If I do not exist, there is no possible way for an entity to walk on me because I do not exist. What? How can it find an edge if I don't ever have an edge? Or corner, whatever you want to call them. It's impossible. I do not see that. Yes, exactly, and that's the whole point. We agree. No, what? We disagree. Node set render surface vertices. A cell with no vertex, all solid interior or all empty, isn't a node and can't be walked on. The render mesh and the nav mesh share the same set of cells. Neighbor adjacent cells that also exist have a vertex. You probe the surrounding cells and keep only the ones in the map that non-exist, the ones simply that aren't neighbors. Yes. So the only thing I was correcting, the number of possible neighbors is 6. The fate adjacent cell not, but it said that it could be 26. That's dumb as fuck again. The face adjacent cells, not 8. I didn't never said, okay, whatever. The 8 is corner of all cells, which only, but you could have, can you not have 7? You have 7. But 7 is not equal to 0, and 7 is not equal to 8. Two different counts, that's the crux. Corner solid count. Seriously, how many of these cells 8 corners inside the sphere? 1 to 7 surface crosses. The vertex exists, so yes, 7 is valid here. This decides does the node exist. Yes, so it can exist. Neighbor count 0 to 6. How many of the 6? Right, but if there is one that has one neighbor, but it can still go to someone who has multiple neighbors, so it should also be possible. How many of the 6 adjacent cells also have a vertex? This decides who the node is connected to. There are unrelated numbers about different things. I think they're about the same things. Corner solid count, about my 8 corners, range 0 to 8, a vertex exists if 1 or 7. Neighbor count, about my cells, 6 cell faces. Why cell faces? A cell with 7 solid corners exists, still has at the most 6 neighbors. Because a cube has 6 faces. But what are we talking about? Okay, wait. I always forget the concept about that the voxel is at the same time it's a voxel, it's a cube. I mean the voxel is a cube, but at the same time it's supposed to be a vertex, which are not the same corners as positions. Oh, okay, I got it now. Because a cube has 6 faces, there's only 6 cells touching it face to face. The 7 is a property of the cell corner. It says nothing about many neighbors around it. So 7 is a valid existence count, but neighbor is still 6. Right. So a vertex position of node center node can have 8 vertex corners. I need to use the same word because that's the thing, it's confusing. But a node can have 6 neighbor cells, which are vertex center nodes. Fucking hell. Exactly right, you had it. No center vertex of one cell. The cell has 8 corners. The scalar samples that the sides exist solid. That node has up to 6 neighbors. The center vertex 8 corners. The sides. If this node exists per cell sampled 6 neighbors. The center node. Okay, so the center nodes of the adjacent cells. Nav mesh graph. The nav mesh graph. So when somebody asked, I'm inside this, but yeah, okay. Yeah, now there's the discrepancy. Okay, now there's the problem. How do I get the mesh from that will work with the node graph? Corners are samples, neighbors are nodes, different things, different counts. Yes, that's what I got now. I forgot. These are surface nets that are like actual nodes or indices, but they're not vertices. That's my problem. I'm thinking that they're vertices, they're just node points. The mesh and the graph came from the same cells. That's why they're consistent. The difference is just how you connect them. Graph edges. This cell and its face neighbors both exist for breadth first pathfinding. Mesh quad. Mesh quad. The surface across this grid edge. So stitch the 4 cells around the 4. Which are these 4 cells? So stitch the 4 cells around the edge into a quad. No. Oh wait, so does it mean that if I do, let's say these are the things I generate, right? We'll do something simple, just a flat thing. So the 4 around, does it mean like I would go like this? And this would be 1. And then when this gets into here, this one would be here. You would have... Does that mean like that? Because who do you belong? Well, I guess you would always... Yeah, you could do that. But will that actually work? So stitch the 4 cells around the edge into a quad for rendering. Both only ever reference cells that have a vertex, so an enemy walking the graph is always walking on rendered surface. Now the mesh gets built. A grid edge is the line. A grid edge is the line between 2 corner samples. The surface crosses its when one corner is solid and the other isn't. Corner is not solid and B is solid. Corner B is solid. It's not so. What? They're not the same. Every crossing edge is shared by exactly 4 cells. Every crossing edge is shared, and all 4 are guaranteed to have a vertex that surface passes through all of them. But I cannot really do, because how do I decide if I have a vertex or a node here, and then let's say it's 3-dimensional, right? So that means I will have 1 here, 1 here, 1 here, 1 here, 1 here. And not only that, but I still will have like 1 bigger ones over here, right? And then I will have smaller ones in the back. We're making actually smaller. Well, that's barely visible, but that's okay. So yeah, at most I can have, if this is the node that we're focusing on, right? I can at most have, wait. If I'm focusing on that one, then I'm always going in the plus direction also. So it's this one, this one, this one. And then it's this one, this one, this one, this one. So I can have at max 7 these as my neighbor point. And then it says to every cross, how does I surface this create? So stitch the 4 cells around the edge into a quad. 4 cells around into a quad. Which are those? Is it like these ones over here? How do I know which ones I care about? Which are the 4s that I care about? Or 4 cells? But these ones are like its neighbors. Yes, so these are 4 cells. And I'm supposed to stitch those around us to a quad. But I have more. Okay, let's not even read. Let's figure this thing out first before we read more, because I had that wrong understanding. Surface crosses this, but a node can have 7 points. Wait, 7 points, or is it talking, or are we talking about the 6 neighbors? Then for neighbor nodes, cell centers, not corners. But you can still have 5. So how do I know to do that? Irrelevance. You now have 3 separate things. Don't merge them. What the fuck? 8 corners. Samples decided if the node exists. Simple. 6 neighbor face. The face adjacent cell centers nodes the path graph. 4 cells per edge. 4 cells per edge. But what is an edge then? 4 of those neighbors nodes grouped. Space. 4 of those neighbor nodes grouped. Grid edge, the line segment between 2 adjacent corner samples. The 8 corner lattice point 1 unit apart, not the triangle edge, not the graph edge, a line between 2 sample points. Corner x, y, z, corner x plus x, y, z, plus x plus 1. Okay, this segment is 1 edge, the plus x edge. The surface crosses the edge when its 2 endpoints differs. 1 corner solid, 1 not corner. Okay, I think it's jumping too far ahead again. I'm still trying to figure out what the fuck how those damn triangles get to become an actual triangle that I can render from this. Why 4 cells share 1 edge? 4 cells shares 1 edge. I cannot see that. Well, I guess no, because there's 2 different ways they could share. There's 4 different ways they could share an edge. Look down the edge, and on the edge is the center dot. Why 4 cells share 1 edge? Picture a single edge of the lattice as the shared spine of 4 cubes placed around it. I don't think, like 4 tiles meeting at a common crease. Any interior edge of 3D grid is touched by exactly 4 cells. The 4 cells around this 1 edge, but you have like 2 edges there that they share. Am I wrong? Each of those 4 cells has its own center vertex node. If the surface crosses the edge at all 4 straddle the surface, all 4 have a node. But that's still a bit wrong, isn't it? All 4 cells straddle the surface, all 4 have a node. You connect those 4 nodes into a quad. So the chain is corner sample sits on the lattice point. An edge joins 2 neighbors. But that is incorrect. Now the node is 0.5 away from the others. And we use whole Unless if it's taking the approach that I just thought about with the... If you're doing the nodes like this, you can still do like this, right? What the fuck? And then you could do like this, then you could have it surrounding. But I don't know if that's the right way to do it, because then... Okay, I guess you could do that. But which one of these do I choose? Do I choose the X or the Y? How do I know that? Let me see. No, inconsistency. The node has two coordinates with two jobs. Don't conflate them. Cell index, whole integer, key map, lookup, neighbor graph, node position. No, but that's now it's doing something different again. Words drawn, the mesh vertex. No. Using adding. And even if you did, you do it dual nodes. So we still and get the 0.5. That's all. Why 0.5? Are there any good resources that would explain this maybe? Because I think this is agreed, drop the 0. Every node gets the same offset, it cancels out and buys nothing, just put the node at its integer cell coord. Neighbors graph and mesh all use the same whole number, simpler, and then the surface looks identical. Uniform shift is invisible. The only thing the 0-point proper relaxation would never buy is smoother mesh that hugs the real sphere surface. Skip it until the block will actually bother. Do you got some specific sources? Resource. I think I need more visuals. Strain. The Naive Surface Net write-up has side-by-side cell vertex diagram and live demos. This is the source most others copy from. Boris Brave's smooth voxel mapping surface nets and his dual contouring tutorial. The clearest diagram of dual relationship sample grid versus cell center vertices, the cell 4 cell per edge quad, exactly the corner versus node confusing you hit draw out. But those are not. Vision League won't help me here because I've seen that one. But look at these two. We probably want to be looking at our actual thing, not that. But Miguel is just looking that, and then yeah. Let's see, but this is now you're greedy meshing. I'm not gonna. Not quite what I'm looking at it, or interesting. Okay, I think this one is more like it, I think. Mapping a technical deep dive, real-time surface nets and texturing. Oh, texturing actually, if it... Smooth voxel terrain part 0 FPS. Let's see. This one talks about. Yeah, I didn't think this one was quite clear. I tried to read it last time or just skimmed through it. I didn't really do that much more, but dual contouring. Yeah, I'm saying contouring, yeah. And then let's open all of these. What? At a time. Okay, let's see. Which of these makes sense to read? Let's see. I wanted the one you already had good for. I think this is voxel surface nets deep dive. Modern lots of render visuals of cell. Like for later, if you want sharp edge, naive surface nets can't do a 90-degree turn. I think this one is really good, and then that one is also pretty good. I just don't have the full picture yet. Okay. Let's see. For the past year, I've been working with Amethyst engine, not just on voxel stuff, but trying to make a game that uses voxels to simplify art process. I'm not an artist, but I know that procedurally generated content is a thing. I started off with a Minecraft-like map that could be meshed with a simple algorithm that generated a quad for each visible face. Then I extended it to the greedy mesh algorithm, proposed it in the 0 FPS blog. I wrote some code that procedurally generated dungeons. I used it wonderful no enclide library to make bounding volume hierarchy of access line boxes for doing collisions and raycasts with the voxels. Everything was going well. Somewhere along the way, I realized that I wanted to put smooth ramps or stairs between plateaus in my maps, and the simple cubic meshing algorithm I had didn't work for that. I drastically reduced the size of my voxels. I could give a slope effect, which was really just a set of tiny stairs. I also considered extending my meshing algorithm to understand slope voxels, but without more complex indexing logic, I wouldn't be able to greedily merge the diagonal quads. So this definitely wasn't an insurmountable problem, but instead of taking the easy way out, I took an opportunity to explore the world of smooth voxel meshing. I think I fully converted. All of my work has accumulated in the voxel mapping project. I'm going to explain how it works in detail. The voxel mapper is a set of compatible systems for creating beautiful voxel worlds. Supports both smooth voxels and cube voxels. Just edited mesh node resource. And then this thing doesn't work. Voxel data structures. First, I'm going to give you a quick background about my voxel data structures. The most cache-friendly storage for voxels is simple array. Every voxel in my game is stored in a std vec, and I have nice wrapper objects that lets you index using 3-dimensional coordinates. If you want to represent a potential infinite world, you can simply hold all of it in an array. If you want to represent this potential infinite world, you can't simply hold all of it in an array. So like many other voxel engines, I partition the world into chunks and all of the same shapes. Some chunks may be vacant, taking up no memory if the world is empty there. The simplest data structure to facilitate this is hash map of chunks of voxels. So effectively, my current data structure is just a hash map point vec voxel. Yeah. The point contains the coordinates of the chunk. Yeah, and then I choose my chunk size to be a cube of 16 to the third voxels, 4 bits in each dimension. So I find that chunk from any voxel point P by masking the leading 28 bits in each dimension so far. So for example, the point would live inside the chunk at key. Okay. It's that simple. You can go further and implement sparse voxel lock trees, but I haven't found it necessary yet. I have made all my voxel data structure and algorithms available on GitHub under the building blocks repository. But what data actually goes in a voxel? We'll discover that as we learn what is required of a voxel in order to draw it. Meshing algorithms. So how can we take a voxel map and make a smooth mesh from it? There are many resources on the internet that provides source code or prosaic explanation of the various algorithms invented for this purpose. I found the most useful resource was again 0fps in the wonderful World 2-part series. You should read it if you have the time. But again, I don't really. Oh wait, this is part 1. Ah. Ah, that's great. Oh yeah. Hey, where is it? I don't have it open over there. But unless you are a real smarty pants, it's pretty hard to read one of these articles and be ready for implementing an algorithm by yourself. Too many details are left out. There are edge cases where the mesh don't line up or chunk boundaries. It can be hard to optimize these algorithms for real-time performance, and once you have a mesh, how do you texture it? How do you calculate normal vectors? I want to cover all of this stuff here. Hopefully I can make it understandable, but there is no replacement for reading an implementation in code. I'll give you one of those too. Ah, music died. To summarize the problem, you are trying to find isosurface zero-level set of a three-dimensional function called sign distance field. That's crazy. So it's a three-dimensional analog of an isoline. It's an isoline. This curve along which a function has a constant value. Okay. It's a surface that represents points of a constant value. First entry velocity density with the volume of space. In other words, it's a level set of a continuous function whose domain is tree space. And then level 0 of it. Level set. Let's see, where do we have the level 0? Let's say anything. Well, okay, I guess it's okay. Whatever, we'll get to it. Probably you should read it if you have the time. Wait, where was I? There. Function called sign distance field. At each point, this function is defined as this distance from that point to the nearest point on the surface of a volume. The points where this function is positive are considered outside of the volume, and points where the function is negative are considered inside of the volume. The volume surface is precisely the set of points where the function is 0. The isosurface. Yeah, isosurface. It's called the isosurface. Does it say? Yeah, okay. The most pervasive isosurface algorithm is marching cubes. Well, fast and relatively understandable if you copy the lookup table instead of figuring out all 250 cases yourself. As naive human, I found that naive surface net algorithm to be a bit simpler to understand, and it apparently generates fewer triangles, so that's a plus. I think optimized implementation of marching cubes and surface nets will be competitive based on the benchmark provided in the 0fps article, so you probably don't need to worry about that if you're trying to choose between these algorithms. Maybe you think marching cube is simpler and better than surface nets. That's okay, you might be right, I don't care. I'm going to talk about surface nets because that's what I know, and everyone else has already talked about marching cubes to death. I haven't been able to find really a comprehensive tutorial on surface nets anywhere on the internet, so I'm going to try to do that here. it's worth mentioning that there is an even fancier algorithm that's so hot right now. It's called dual contouring. Well, I had to put a pause there. Of Hermit data. It's actually just an extension of surface nets that uses extra information about the derivative of the sign distance field to better approximate sharp features. I haven't gotten around to try it yet. Maybe one day in the future. I think might have to. Well, we'll see. This summary of surface nets is that you look at a grid of cubes, and for each cube you decide if and where an iso surface point should. Wait, summary of surface is that you look at a grid of cubes. Okay, we have a grid of cubes. And for each cube, you decide if and where isosphere points should be inside of that cube. Or once you have all of the isosphere points, you use them as the vertices to make a bunch of quads that ultimately form the surface mesh. Note, my words will be described. Will describe the third algorithm, but my picture are going to be mostly in 2D for this part because it makes a lot simpler visualization and draw. So when you see a square in the picture, think a cube. Think cube. Finding the mesh positions. So the first step is to understand what the grid of cube looks like relative to your input. Our input is a third-dimensional grid of voxels. For surface nets, you should imagine that each voxel is actually not... That's pretty crazy. This is... yeah, okay. For surface nets, you should imagine that each voxel is actually not a cube, but instead a single point in 3D space. The same 3D space where we would define the signed distance functions. The point is a corner shared by 8 cubes in the grid. 8. The point is shared by 8 cubes in the grid. That's also really hard for me to understand because shared by 8 cubes in the grid. How can you get 8? If you put it here, then this one is sharing it, this one is sharing that one, this one, this one, this one, that one. Oh yeah, it is 8. Okay, I see now. Yes. So each voxel must store the value of a signed distance function at a corner in the grid. Now we know one of these pieces of data to store in our voxel type. Don't worry, we're not going to store an F32. Now for each cube in the grid, we need to determine where we would find an isosphere's point, if there is one at all. We can look at the 8 corners of a cube. 8 corners of a cube. Okay. And if there is a mix of positive and negative distances at those corners, we can say that there must be a surface point somewhere in the cube. Okay, that makes sense. Yeah, this still makes sense for me, right? Pink dots. Oh wait, this had the voxels are the plus and minuses on the corner of cubes. The pink dots are surface points. Note that there are only a pair in cubes where the corners don't have the same sign. Oh. So we can look at the 12 edges of a cube. 12 edges of the cube. 12 edges of the cube. How many edges does a cube have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, they do have 12. And we know that if an edge connects 2 points, voxels, and we know if an edge connects 2 points, voxels, with different sign, then by the intermediate value theorem, there must be some point on the edge which has value 0, i.e. the surface point, and the edge intersects the surface there. But what the fuck, how does that make sense? if I do have, let's say cube 1 and cube 2, and then this one is plus and this one is minus. Oh yeah, so somewhere in between here there is a 0. Okay. Would take all such edges in the cube and average their surface intersection. We take, wait, what? We take all such edges in the cube, but the edges are not inside the cube. Wait, we take all such edges in the cube and average their surface intersection point to get an approximate surface point that lies inside the cube. That doesn't make sense to me at all. What the fuck? Points to get an approximate surface point that lies inside of the cube. What? What do you mean? If there are no edges, then we skip this cube, as it does not contain a surface point. But what do you average on? Like, that's the thing I don't get. Let's see. Oh my god. What does it mean to take edges inside the cube? There are no edges inside. And then up? What? What? Average. Average. Okay, whatever. Pink line segments from this. Pink line segments form the surface. Yeah, that makes sense. In 3D they would be quads. Notice that the surface only crosses cubes edges where the sign changes along the edge. The edge inside cubes, 12 edges of the cube itself. The wireframe line connecting its 8 corners, not edges floating in empty space. A cube has 8 corners and 12 edges. That makes sense. Each edge connects 2 corners. Yes, if these 2 corners have different sign. Oh, that's what they meant by different sign. Ah, okay. Ah. Difference on one side. Okay, so it wasn't this, that if you have to like this minus and plus, it's not this edge, but it's, wait, but how? Yeah, so if there was, but how do I figure that out? But yeah, this one has one edge that is minus here, and then it would be plus on this side, even though the node itself is okay. One side the sphere, one outside. Surface must cross that edge somewhere between them. Surface intersection point, where on the edge the value hits 0. You find it by interpolating between the two corner values. T value minus value B, 0 along the edge, cross point corner A multiplied by T corner B minus corner A. That gives you one 3D point sitting on the edge right on the surface. Average them. Collect the crossing point from all the sign change edges. Wait. That's the also averaging them. Isn't there just one point here? Like, this is the only edge here. Or is it, am I supposed to, then also this one shares it, and then you have another one. So you have actually like, how many cubes can share one edge? You can have one over there, one over there, one over here, one over here. So you could have 6. No. I need to see this in like my head instead. Yeah, 4 cubes can share one edge. Is that what it means? Average them. Collect the crossing point from all the sign change edges. A mixed cube has everywhere from 3 to 6 of them. What the fuck? No, it's talking about something different. Add them up. Divide by the count. 1 point inside the cube that hugs the real surface. That's average point is where you place the cell's vertex. So this is the better version of what we lazily replace with just we use the cell center. Center is the crusade. Why do you only have 2.2k subs, man? Hello, Geo guys. Yeah, I'm not that good at. I'm still learning. I'm not too good, okay? I'm still learning. I'm also thinking about what kind of video I should make, but with time, I believe. I have to try something new. But I'm kind of like hooked on trying to figure out these things. But yeah, okay, so I'm still a bit stuck here with this part. I don't know if I want to read. Let's talk more. So how do we calculate the intersection point of one edge? Okay, maybe it actually gets to the point, but now it kind of makes sense what he was talking about, the edges. Thank you. Now this makes sense. Okay. So yeah, okay, we'll talk about it. I mean, I just found out your channel, and yeah, I'm in love with it. Oh, you are? Wait, do you mean the what specifically? Because if I could know that a little bit more, kind of could maybe figure out what to make more of, or yeah. If it's okay if I ask, because I'm just still trying to figure out, like, I kind of like to do what I do, but also try to figure out what I could make that other people would enjoy a little bit more. So, as you see, I haven't uploaded in a while. I have a few videos that I started, but I was like, not really maybe what I should be making. I don't know. Yeah. I have like 3 videos that are like half done. I'm like, nah. Or not half done, but they have a pretty good start. I made a triangle using Vulkan video. Okay, you like that one. And also the stream is super delayed. Oh, shouldn't be that delayed. Wait, let me take a look quickly at the... Yeah, maybe it's confusing because of the delay. Yeah, it's understandable. It could be maybe just YouTube, because usually Twitch is up to speed on this. Wait, I'm gonna check real quick if I can. How delayed is it? Okay, and let's see. I'm gonna check out Twitch real quick. Can I see myself there? Let's see. Yeah, I think that Twitch is actually more up to speed than YouTube. Funny. But yeah, okay, the triangle one. Interesting. That's one that's actually quite old. Well, year 2, maybe? It was like actually just the first time I ever made a Vulkan application or anything like that, so I didn't really know what the fuck I was doing, so the video is also like, I don't know even if I'm talking facts or what I'm saying in the video. It's I'm just like, I'm just gonna say something and hopefully it goes good, right? Maybe, I don't know. I will have to think about it. I should probably just stop thinking and start uploading. But yeah, at least the thing is, I enjoy doing the streams because then I can just program and do the thing I want to do, and it already like pays off on its own. Like, I feel like I get more response from streams than from videos nowadays. I will think about it. I will continue now reading this thing and try to figure out how to do these surface nets. Thank you for the comment though. It's really nice. So how do we calculate the intersection point for one edge? This is where the actual distance values comes into play. Technically, we only know the distance from a corner to the closest point on the iso surface. This is the definition of a sign distance function, but that's not necessarily the point of surface edge intersection. The point labeled PS in the diagram below. PS? What the fuck is... Whoa. Point 1, point 2, but then there's some... Oh, this is actually where the surface goes. Okay, so we can figure... Yeah, okay, I see now. Okay, we can't have enough information in our finite grid to calculate the exact intersection, but we have... What if we make the assumption that the surface is approximately flat in the neighborhood of the intersection? This is true in the limiting case for manifolds, which is why you get better approximation as the grid resolution increases. What is... You get better approximation as the grid resolution increases. Yes. Consider the diagram below. Super chat 100. Here is a gift. Keep up. Thank you, thank you. I will. Thank you for the super chat. It should, or I think it's, wait, stream elements only do you only have the Twitch, or does YouTube also have like a pop-up for? Now it's blurry. Crazy. Oh my god. Doesn't want to focus. Oh, okay, maybe. Twitch does at least have the overlay sound when somebody does a donation or something like that. I don't know, YouTube doesn't have it. Maybe I just don't have it set up. But thank you nonetheless. P1 and P2 are corners of a cube. Yeah, that makes the edge between them intersecting the surface PS. F is a sign distance field function. F, okay. The perpendicular dotted lines indicate the distance from P1 and P2 to the surface. Okay, that makes sense, yes. We see an edge connecting two corners with 3D coordinates P1 and P2 with the respective sign distance values D1 and D2. Okay, the surface intersects the edge as a point with coordinates PS. Yes. By similarity of the triangles, the ratio D1 over D2 should be equal to the ratio P1 minus PS over PS minus P2. D1, aren't D1 the same as P1? Confused. Coordinates P1 and P with the respective sign distance values D1. In fact, this is only the ratio that... Okay, I think I will have to ask a little bit about this. And D2 equal P2. And they are not the points, they are the sign distance values, plain numbers measured at those corners. At the surface, wait, field, wait, what the fuck did it? Measured at those corners. P1, P2, 3D positions of the two corners vectors. The scalar value of your field at each corner. How far inside, outside the surface. Ah, okay. For sphere, the sign distance is distance to center minus radius. So inside negative units, outside positive, D2 units outside. The surface is where the value 0, so PS sits between them closest to whichever corner that has the smaller magnitude, that similar triangle ratio. P1 minus PS, yes, and then PS2. PS minus P2 is the same as dividing the sign distance field between them. But then we are assuming that PS is then a point, or what is that? Because this is a point. But then PS should be 0. Isn't that where we find the 0 point, or what does, or is PS the point? Or no, wait. The value at PS is 0. That's the definition of the surface line distance 0, but the PS itself is a position, a 3D coordinate, not 0. Okay, don't mix the two again, the same trap as D versus P. Okay, then that makes sense then. Yeah, so then we just take the point, yeah, that's equal to that. So we have a point 1 minus that, and then we have this point minus that, and then if you divide it, you should get the same ratio. Yeah, that makes sense. In fact, it's only the ratio that we need to calculate the point of the surface edge, the section. So we use the linear interpolation to find the point on the edge where the design distance must be 0. So what PS was divided by that, and why do we have multiplied by P2 minus P1 and plus P1? Don't we just want it equal to 0? Note, D1 over D1 minus D2 is the same as minus D2 is over D2 D minus D1. Yeah, that makes sense, but does it? Substitute. What the fuck? It just replaced the PS. I put this in here. But how can it do that? That means it must have found that. But those two are not the same. I do not see that. D1 or D1 minus D2. P2 minus P1. No, I do not see how the substitution works out there. Because if this is equal to that, that means we could put D1 over D2, but they put D1 over D1 minus D2. Where did that come from? Or did they do something else? I don't see anything else going on, so what the fuck? I like the triangle using Vulkan video because I was finding research to learn Vulkan. I have a C++ background, and I think you could make graphics program for dummies tutorial series, and you do have a Discord, but yeah, I do have a Discord for it's right now in the Discord. You just go on my channel and you will find it there. I can also just send it if you want to. Wait, fuck, I'm struggling. I mean, I could probably make a graphics programming for dummies, but yeah, I mean, why not? Would probably start with something very basic and simple. I don't know, like, there is a really good new one that is like 2 hours long, which I am kind of like watching. It seems really good as it is already. But yeah, that could also probably work, yeah. I was thinking about doing something like that. I'm still not that good with graphics programming. I just implement and add stuff as I go, and feel like, now I need to do this thing and that thing, and then I add it. And I'm actually like quite lazy. I still avoid doing the descriptor sets and descriptor pools because I find them dumb. So I use shader objects and what's it called? device address buffers. Yeah, so if you don't know what that is, just it's just something really annoying to deal with in Vulkan that I don't like, and then avoid them by using more modern features that lets you. But I still think they are still better. That's, I don't know. I just don't like to deal with the damn descriptor. Descriptor layout. You need still the descriptor set layout and pipelines layouts. You don't need to, with shader objects, you don't need to create the actual pipelines. You can just dynamically during runtime change how the pipeline kind of works. Of course, some things you need to actually create, but some things you can dynamically change. It's mainly the layout that is kind of like locked in. You don't need to be good at, you just need to teach what you know, because there are not much videos, tutorials, and a lot of people are just not good with reading. Maybe you're right. But also, it's kind of like the people who mainly watch videos are people who kind of just want to get, that's not true. No, I don't know. I was thinking if you probably want the fast result, and I was thinking maybe do something funny like about how different things inside of Vulkan, different handles, basically what they mean and represent, and why you create them in some kind of way, starting from the device, because that's physical device. That's the first thing that your application is actually the first thing you would have to go through. But then talking about the physical device, logical device, and like from there, like building up to more like how to do how to start Vulkan 101 or for dummies or something like that, and then just memeing the shit out of it. But I don't know if you can learn that much then at the same time, you know? I would have to plan the whole series and everything, but I could do it. I think that could probably be good. Also for myself, I could probably learn something new about the. But I don't know if I should do like modern Vulkan also using shader objects in that tutorial, because I think I found them really good. Avoiding the damn descriptor sets. Fucking hell. I hate them. I hate them so much. Does I do anything to avoid to use them or create them? No. And again, that's just it's not directly associated with shader objects. That's more the pipeline, but still. Series will boom for real. I probably would, but the thing is that there's not many people who, I guess there would be like 60k views, I think, around. Probably I could get in the first video, like people who wants to start. Like there's not much views you could get on a Vulkan tutorial series, I think, there, because it's so niche. How many people would like to watch it? Or maybe that's because it's so hard to understand and follow along. That's why there's not many views on it. Just in my experience, I think that's what I see. It's not many views, right? But I don't see how this happens. How does this happen? Finding the surface edge intersection point with linear interpolation. PS is equal to 0.1, and then the ratio plus the ratio multiplied by 0.2 minus 0.1. I believe me, it can get up to like 100k and more. It just that's getting started with it is so hard. No one even tries. Yeah, I mean maybe one day. Probably it is on my idea list to do. Then, like I said before, we do this calculation of PS for every intersection. But I'm still so confused. How does that work? How does this thing work? How do we go from this to that? When they say that this is that and that is what we got over here. And somehow that becomes this But that shouldn't be the case because it should be this d1 over d2. And d1 over d2 is not that. Oh, wait, I'm dumb as fuck. I just added... No. Nah, I do not see it. I do not see it. Because if you did a... multiply the minus d1... If you added a minus d1 on both the top, the numerator... Can you... I don't think that... No, you cannot do that. Could you... Well, then you would get a 0 at the numerator. That wouldn't make sense either. Nah. So how does this work? How do you get that from that? Doesn't make sense. Not at all. Or does this equation just... Should I just say that this equation just exists? The fuck? Okay, maybe I will just go with that for now until if I actually see that it's a problem for assumption later on. But it will do finding the surface edge intersection point with linear interpolation. Sure. Then, like I said before, we do this calculation of PS for every intersection edge, and we find the average of all of those PS. This average is the surface point inside the cube. But why would you do an average on it? You already have that one segment. That's Find an average of surface edge intersection point. Calculating mesh normals. I'm just gonna look a bit further ahead. Let's see what it's gonna talk about. It looks pretty good. Okay, let's see. Calculating the normal is actually quite straightforward. If you remember your multivariable calculus, vectors orthogonal to a level set are always gradient of the function. Whatever that means, sure. I have done multivariable calculus, but I did it in Swedish, not in... But it shouldn't be that hard to translate it, but still I have. For a function with a 2D domain, you can imagine a topographical map. The level sets, curves of constant altitude are always orthogonal to the gradient vector, i.e. the vector pointing in the steepest direction. So for a function with a 3D domain like our sine distance function, the isosurface is a level set. And its normal vector are gradient of the sine distance function. Right. I think I got it. Maybe. So we'll approximate the gradient at a surface point by looking at the same set. The gradient is at a surface point by looking at the same set of 8 corners. So to get the x-coordinate of the gradient, take the sum of the difference between corners along edges in the x direction, likewise for y and z. What? There says do no. D01, D11, D00, D10. Okay, yeah, okay, so it's okay. Nx, so this one minus this one plus, wait, what? Oh, that one, my bad, I did it the wrong way. Approximate the normal vector components in D2, the D value are the sine distance at each corner. Building the mesh triangle, the final step is to write out an index buffer that defines all of the triangles in your mesh. Get yourself apt, because this is probably the most confusing part. This has been confusing all the way already. Again, we will look at edge. We'll be looking at edges of cubes, but in a slightly different way. We will iterate over all of the surface points we found before. A pseudo description goes like this. For is it PL or P1 in surface points? So all of the surface points for axes in axis, x-axis, y-axis, z-axis Okay, so now it's talking about the same thing that Claude suggested, which I didn't understand. But okay, apparently you're supposed to go through every single axis. You have the 1, 0, 0, 0, 1, 0, and 0, 0, 1. And then edge, get a cube edge in the direction of axis. Okay. Quad, get a quad orthogonal to axis of surface points where P is the maximal corner. Where P1 is the maximal corner. If edge is minus plus or the edge is plus or minus, is according to mesh. But which cube edge and which quad are we looking for? The easiest way for me to describe is with picture, and they are in 3D this time. This is so confusing. What the fuck? One of the 3 possible quads at P1. An edge intersects the quad. The edge is shared by 4 cubes, and the corners of the quad are the surface points inside of each cube. One of the 3 possible quads. How is there 3 possible quads? An edge intersects the quad, the edge is shared by 4 cubes, and the corner of the quad are the 4 surface points inside the cube of each cube. There can be up to 3 quads found to surface point. Okay, so we always assume a positive direction of where we want to do the thing. We never do an assumption of towards a negative direction. Okay, that's okay. Hopefully that picture gets my point across, and for fun, here's the 2 analog and our view. An edge intersecting a surface line segment in 2D. The edge is shared by 2 squares, and the endpoint of this line segment are the surface point inside of each square. At least in my implementation, I look in the negative direction from P1 to get the other quadrant corners P2. Be careful on the boundaries of your grid, since there may not exist surface points in the direction you need to look. Once you have your quad corners, you need to write the indices of those corners into the index buffer. Once you have your quad corners, you need to write the indices of those corners into the index buffer in winding order that points the normal vector in the correct direction. You will in fact be using 6 indices to make 2 triangles. I will. Give me some real code to look at. It's one thing for me to blather on about the algorithms, and another for you to understand it concretely and enough to implement it. So I might as well just give you the cheat sheet. Here's my implementation of SurfaceNet. Sorry I didn't provide any snippets in the article inline, but it's kind of hard to make sense of them without seeing all the code at once. SurfaceNet's chunks. Oh, recall that our voxel map is a set of chunks. Well, I'm not even at that stage, so SurfaceNet is an algorithm for extracting an isophase. Actually, I wonder, I could actually do one thing here. Because should I actually not start from minus? Do I use clamp size anywhere else? I think this should actually be start position. Let's change it. Const start. I'll just call it start. Take it. -1. I32. Start. That should hot reload also this one. I think. Yeah. And it should probably look a little bit better. $227, maybe it didn't. But I think it should be like that. Then for extracting iso surface measured from a signed distance field sampled on our regular grid, it is nearly the same as dual contouring, but instead of using Hermite derivative data to estimate surface points, surface nets will do a simpler form of interpolation average between points where the isoperic cross value cube edges. Benchmark shows that surface nets generates about 20 million triangles per second on a single core of 2.5 GHz Intel Core i7. This implementation achieves high performance by using small lookup tables and sim the acceleration provided by GLAM when you're doing 3D floating point vector math. Users are not required to use GLAM types in any API signature to run the benchmark yourself. CD bench. High-quality surface normals are estimated by calculating derivatives using central differencing using the binary interpolation of SDF derivative along voxel cube edges. When working with sparse datasets, surface nets can generate measures for array chunks that together seamlessly. This works because faces are not generated on the positive boundary of a chunk. One must only apply translation of the mesh into proper world coordinates for the given chunk. Example code. Okay, so they just... Okay, but where do they do the actual implementation? Let's see. Oh, is it Rust? Okay, I got to learn a little bit of Rust syntax then, I guess. Sign distance to surface net buffers, positions, normals, okay. Strides, surface net buffers, surface nets. Let's close this, and let's duplicate this one. I can go in here, I can close that one, keep this one open, we can close this one. So what do they call? The const shape U32. 16 shrunk with 1 voxel boundary padding. There's the one thing I didn't want to close yet, but I closed it by accident. This thing. It's a geometry, probably there, maybe. Hungry and tired. Whew. Let's see. Smooth voxel meshing algorithm extracts an isosurface mesh from the signed distance field. So SDF shapes mean fixed references and estimate surface in cube. Where's the like actual function to create the thing? Make all quads. Maybe make quad. I mean, it has to be that is the first. Surface nets, let's see. Make sure that slice matches the shape before we start using blah blah. Estimate surfaces, make all quads. What the fuck? Wait, can I read? Let's see. So SDFs, I assume this is where we begin. I think. In this file. Shows that yeah. But that's wait, no, what the fuck? Output buffer used by surface nets. SDF shape. So you provide a shape linear size, mean shape linear size max. Oh yeah, just make sure. Okay. Shape linear size max as use size, SDF len. Okay, reset. So you reset an output, surface nets buffer. And then estimate surfaces. Let's see. So set y x stride shape linear size. What is a stride? Do I care about stride? And then from there it just creates this vect and then estimate surface in cube. Output stride to index as use the output position. Source output stride to index. And then surface point and then surface strides. There's a stride to index and surface strides. That's funny. And then else stride to index. Let's see, what does this one provide us with if we... Guess just linear size, I have no idea what it does, but it probably gives me just some... Is it just length or something like that? So how long that is? The normalized vector? I don't know. And then estimate surface in cube. It's this thing over here. We get in the SDF, the shape, the point. Let's see. The P at a point, and then mean corner stride. And then set output. Wait, what? Okay, so just taking the output surface net buffers. Okay. And then get the sign distance values at each corner of this cube. For each this in corner, this iterate mutable enumerator, corner stride min now, but what corner stride? Min corner stride shape cube corners I. So there's just like a quick lookup table. Oh, so you get all of the... Oh my god. That's basically the same what I'm doing here, but just like better. What the fuck? What is that corner stride and min corner stride? Where did the min corner stride come from? Min corner stride is from... Okay. So yeah, you do have your own distance and then you apply that lookup table thingy. I think it would look a lot cleaner. Corner destination iterator enumerate. Where does this come from? From here, so you just say, is that like a tuple array? And then you just take the I and then with the dist you do D into Get unchecked corner stride as size. So then you just okay, and then if D is negative, num negative plus minus 1. And then if negative, okay, so use negative instead of checksum. I think that's also pretty smart. It's pretty much the same thing, just different naming of all of these things. Okay. But what is the corner stride? What is it that it's storing? It's storing like linear size. I really want to know what that is because that's kind of like I can't find where it comes from. I just see it. I'm like, ah. Engross linear size is a typical reference to one of the two distinct conceptions on enumerating discrete types into integers or linear and dynamical coordinates of an array. Enumerating types of linearized crate provides a trait and derived macro defined bisection between an enumerated type and an interval of natural numbers. This allows complex keys to be used in high-performance non-allocated maps like static map, static copy map. Not quite sure that's actually what I'm working with here, but let's see. Let's see. Gonna take let's see what is stride here. Oh my god, that's not what I wanted. Let's see, I'm gonna copy paste a few times. What is stride here and linear size? In this code, block mesh rasta is about the 3D grid in a flat 1D array. Linear size converts a 3D coordinates into a single flat array index. Index, oh, width times height. Okay, interesting. That's how you map a 3D position to one slot in a vector. The function shape linear does this math for whatever the grid dimension are. Stride the result of that, the flat index of the current voxel xy set into Alright. The name is a bit misleading. There is really just the linear index of this cell. They keep it in a variable base because they reuse it to look up SDF stride and set the neighbors SDF stride plus 1 next in the SDF stride width. Next in Y and etc. Those offset are the true strides. Oh, that's pretty smart. Yeah. Okay, so instead of just using a hash map to access the actual thing, you can just give a stride. And then you can use that whole integer value to access the same information. So it's elsewhere total element count width times height times depth used to allocate flat array. So yeah. Huh, okay, I see. Yeah, because they will always have to be unique in that sense that you cannot have. Because let's say if you'd say the depth is the largest, you will always go with such a big distance that you're always on a new depth no matter what, and then you will have the height and the width or whatever. So it should always be the same. Or it should always work. Okay, then it makes sense. So then when we work here, we get the stride. So this is basically the index position of the thing, and then we get a point, and then when we go in here and ask for that thing, we go in here, we create this array of F32s, numbers, negatives, and then we enumerate these things, and then we check corner stride, mean stride. So this is like the index that we are at plus, and then here we do get the relative offset, and that will also be a stride into here, and then corner stride, and then so we'll now have the actual one-dimensional index for that specific thing, and then get unchecked corner stride as use size. Corner stride. Okay, so we'll get the corner stride as use size. So we'll get this, and then we'll put it into the destination. Whatever stands distance. Yeah, so we'll have this, and that's the stride distance value at each corner of this cube. But wait, no. Get. No. This should just store SDF get unchecked. Let's ask that also. What is the get unchecked? And then this D into the. Let's use the Rust bound check in skip array access. It's an unsafe optimization. Normal indexing SDF checks I less than len every time and panics if out of range. Get unchecked skips that check straight to the memory faster in hot loop, but if I is out of the bound, I undefined behavior reads garbage, crashes, not a clean panic. That's would run up in unsafe. Safe bound check, unsafe no check. Okay, so instead of just going SDF corner stride, and then what are these SDFs? That's just some. Just some algo that decides if inside or outside. Okay, so we get if it's inside, and then we get dist, and if it's negative here, well, we asked somewhere if it's negative, and then we'll just num plus that, and then if it's 0 or if it's 8, okay, then we get back to there, and this is now per one of these, and then when we get in back to here, yeah, then it returns false if it is not. Okay, and then centroid of edge intersection. Okay, I think we can probably upgrade at least that, because that's a pretty cool. I like the way that it's, but it's one tiny problem with that, which I don't want to do, because then I would have to allocate all of the possible locations. But that shouldn't be too crazy. It should be, I can only have, no wait, but I need an index per possible location. Yeah, so I would have to allocate like crazy amount. Can't do it. I think this is better. Where did I put it? There it is. But I like the table. I really like the table. which is pretty much the same thing that I used to do with this thing. So I can steal it from here. Like so. Cube corners. I think they call it also cube corners. So what? Cube corners, yeah. And it's the same thing. Even in the same order? 0. Doesn't really matter that much, but I guess we can try to do the same corners and it's still fine, doesn't really matter, but if they do show some debug, I would like to be able to debug the same way. Like so. Cube corners, that's so much smarter still though. I think we can still roll. Can we roll with that? Because then there's this question of no, it should be defined. Should be defined. So instead of doing all of these things, we could actually just ignore it. I would like to rename this to be well, checksum is fine, but I would like to go for that list. And then 4 or y false, no, 4 0 to 8 and O will capture I. And we can just go because we do have the OLSP. Cube corners I, but also do I want to work with, I think I'm gonna change that to no, it should be fine, it should be fine. And then we can just ask basically can do this, we take it here, paste it, call it also position, and then we can ask, we can do this, and then we can do a this, so, and then that's fine. These are, let me take a look. There are F32s. So they should be fine to be done like this. Plus. Must have known result type. But this, to get rid of those as well. Or do I just change it back to F32 since that would be better? F32, I mean. Then we wouldn't have to worry about this. Like so. And then we get the position there, and then we can ask if it's solid. Now we can get rid of this while loop over here. Now that logic should be pretty much the same thing. It builds, good, I just want to make sure. And I mean, we could even go in here, and if I do hit spawn a new planet, it does spawn the same planet back. And we should have the same amount of information, which works great. Might, wait, what? Okay, there, new snapshot. Yeah, the same amount of information. There it is. It's the looks. I mean, it looks better. It's better. It looks better, but it's actually like it doesn't really matter. But it looks better. Yeah, but that's at least in code this looks a lot cleaner. I like it. Okay. And then from here, let's see what's the next thing that they do. They store it, but I also store it in my own kind of way with pure vertices, which maybe is wrong. Maybe I will have to store some extra data because they do. Let's see what they do. They store the stride. No, they don't store it. They just check the dist, and if it's not good, they just discard it. But otherwise, they kind of just go, okay, centroid edge, and then positions, push, normals, push. Let's see what the centroid of edge section. Center of edge section. Let's see. They get, what do they get in? They get the corner. They get the corner dists. So they get the full array of all of the corners that was created. So this thing here. So they reuse that information. Okay. And then this counts 0 sum. Okay. And then they check corner 1, corner 2 in cubes edge iterator. Okay, so there's like an edge table, edging table. Destination to 1, destination 2, which is from, you take each of these corners and then you check if and not count +1 sum estimate surface edge iterator. What the fuck? Okay, so there's just some tables. Let's look at this edge table. What is this to begin with? So binary data, just 0 and 1, then 0 and 2, then 0 and 3, and 0 and 4, then 0 and 5, then 0 and... No, wait, that's... No, wait, what am I saying? 0 and 3, then there's 1 and 2, 4. Then there's 1 and 5, then there's 2 and 4, then there's 2 and... is that 6? And there's 2 and 8, 7, I mean. Yes. 2 and 7, and then there's 4 and... I'm actually slowing down. 5, 2 and 6, 2, cool, what is that? That is 5 and 6. And then there's 6 and 7. Oh my god. I'm a bit confused, but okay, there's 12 edges. Okay, so there's the points. Ah, right. So this just gives you a table if you look at that thing a little bit differently, right? So we have a cube like this. And then we go from 0 to 1. So that this has to match 0 to 1. That's this one, it's on the X, so it's this edge. Then you go 0 to 2, 0 to 2, this is that one. So you go up here, and they go 0 to this one, which is the 4th, so that would be this one. Am I thinking that's right? No, wait, that's 3. This is 4. So it's this one. And then you go from... Yeah, so that's why I need them to align also the same way, because otherwise this would not work. Yes, okay, I see. We'll do that. I think we can pretty much just replicate it. We'll do an array of... What do they? They have a pair, so they have an array of... They just have 12. That's a... two-dimensional vector actually of U32s, and then they have those entries inside of it, which are binary values. That's okay. These are not called, they're called cube edges. So I'm still adding lookup tables, even though I thought I was gonna get rid of them. But it just makes the code look way cleaner. What the fuck did I just do? Oh shit. Okay, that's okay. Boom. Bam. Bam. Boom. I should be able to do binary values like that also in Zig, I'm pretty sure. Expected a square. Why the fuck did it not override it? No, whatever. But those are utilities, not floating points. Oh yeah, we do it differently still. Doing it so wrong. Let me just fix that. Let's change it to that. And then change this to that. Oh, that should be good. And that should follow pretty much the same. It's pretty good. Okay, so we can get each edge now. So centroid edge intersection. But then we want to store all of the values that we got for that. So what I actually want to do is here, when I start to go through all of this, is that I also would like to store them like they do there. Well, actually, that's just an array of 32s, right? So I can also just do a cons. That's the array, right? So what do they call it? Corner distances. Sure. Where do not store corner distances? I could store corners instead. Corners. And that would be of an array 8. Let's do nsetback 3. Do F32. Define. And then what we'll also do here is that we'll go from that, and then we'll go for each corners at the same time. We'll capture corner. And then we can change this to just become equal to corners or corner. Will it not be a reference still, so I could do that. Corner. I think so. Yeah, it seems fine. I don't know. I think it's. I need to do that so it actually understands that it's a reference. Yeah. Okay. And then we should just be able to do that, and then we can do same logic that they do there. Checksum, blah blah blah, switch case. And no matter which one we went with, we might care. Centroid edge section. And this accomplishes to know what does it do. We at least got the same information now, so we can get this, and then we check these things, and then count. Count is here. Sum. Estimate surface. Okay, so now it does the thing that I was thinking, like, what the fuck? Oh. So this is how we find out where that's sum. What do we do with the sum? And then we return that, and then we assign it to C, and then the position is P plus C. Well, actually, mine will be the absolute. Is that bad? Because they do P. They do the P. Where's the P coming from, anyways? Where is the P coming from? Ah, P comes in from here, which comes in from here. Which I'm just doing all in here. Okay, I'm feeling like I'm gonna do something very dumb somewhere. Ah. But yeah, so they don't store the relative information here. Yeah, do not do that. But I think I can just do the point plus C. And then normals, I think we can ignore the normals for now. We're not that concerned with that. But let's get that point. But that, how do you push? Okay, I'm just gonna do that. Okay, we'll do that. So we go in here, and we do have the information about the corners now. Oh yeah, I guess we could also get rid of an indentation. It is. We'll continue. And then else we can now, we know here that we're continuing on. So we can do now this thing, which is having a count and then a sum. Okay, let's do that. Our count doesn't tell me what it is, but I'm gonna do a utility. Yo, what's up, Debbie? I'm gonna do a var sum and set like 3 F32, and then for loop, iterate all of them. How are you doing today? I'm fine. How about you? I hope you're good. You're great, right? Could I make this into a tuple instead? That would be convenient. I don't know how to do that, but let's see. Could I make this into a tuple? So I could for loop both at the same time. Yeah, even great. Got some really good progress this week, and I'm so happy. Great! The best thing I was probably that I'm back to 140 FPS debug. Oh, that's great. I remember when you told that it was like 10 or something. These are corner indices, zero not flat floats. Drop, use small and yet small int and yes sig structure, so you can't pull both at once. For edge destruct, you could do that. Wait. Okay, that's true though. I will do that. U32, I guess I could do. Oh no, what did I do? I broke it. U3. And then in here, what are we working on now? We are doing surface nets. So I'm trying to figure out how the fuck to make that work, because right now it ain't looking that good, you know, it's looking pretty bad. But we're getting there, I believe we're getting there. We're getting closer. And when we do that, we get a mesh that we could also use for navigation mesh for the AIs to navigate. I want to make the planet more versatile, so to speak. So it's like different, you know, more heights, cliffs, caves. Maybe not that much yet, but you know, obstacles basically. So it has depth. And then I want to make the AI a little bit smarter on how to navigate in that, and that I believe will happen with getting the nav mesh in the same run. Cool, yeah. Corner 1. Can I not just do this corner? Oh wait, no, 4 corner. Why is my LSB not showing, man? Edge, cube edges. Of course, it's cube, it's not corner edges. That makes sense. And I will capture that edges. And then when we have captured those edges, we can start edging here. Just kidding. Kidding. It's a joke. Const. Corner 1. Could I not just do? If you're going to with the nav mesh, how will you bake it when you loading the scene or no? So I will generate the surface nets, and from the surface nets, I will get at the same time the how do I clear this thing? I always forget. Yeah. So I will make, you know, the whole mesh, whatever this is. This is now the whole mesh, right? And at the same time, this will become my navigation mesh. So I will know when I stand at any of these nodes, which are, I'm still not quite sure what it will be. If it's, I think it will be in the center of one of these. But basically, I will be able to tell. I will take the entity position, take it down to the lowest integer, like floor, the integer position of it, and then I can look up which node is it inside, and based on that, I can know which node it should move to, right? So I will get it at the same time. And it's only the server that needs it. The client doesn't need to know shit about that. It just needs to know that an entity moved. So it's like, okay. It just renders the mesh. So I'm kind of working on just rendering it correctly right now, rather than worrying about the server doing the right logic for the visual stuff. But yeah, corner 1. I rewatched the videos so many times with the guy doing those procedural texturing, etc. Ah, yeah. I mean, it's good that you find like the thing that you kind of like to, you know. Yeah. Actually, what the fuck am I doing? I just need D1. And then I want to do it on my corners that I got. And I want to provide edges. Or edge. Hey, edge. Ooh. And then I want to do for edge 0, the G. And then this is D2. Fuck me, Jesus. Ah. So we'll have both of those now. Yes, that's correct. And then if the D1 is less than 0.0, that's so interesting math here that if, oh yeah, so if this one is a negative, not equal to, so they need to be opposites, right? If they're both negative, it doesn't matter. If both of them are positive, it doesn't matter. That's basically what we're checking here. Let's see. And reverse engineering, that's why. Yeah, I think you kind of need to do that. It's actually quite interesting to, like, so many ways you can find out how to do stuff. Like, you can watch YouTube videos, you can read a blog post, you can ask AI, then you can read source code, try to figure out what the fuck things means. Crazy, right?
Yo, what's up?
Yo, what's up, Tisha? How are we doing?
Good, I guess.
That's great. We are supposed to be doing good.
Wait, Lucas, you need to watch my wallpaper. You didn't see it yet, right?
Wallpaper? No, I haven't seen your wallpaper.
Yeah, watch my stream. This is absolute cinema.
Alright.
Okay, are you ready?
Mm-hmm.
Bam!
Yo! Is it Holy See?
Bro, it's holy C.
But where's C then? If that's holy C.
What do you mean? That's not, and it's C, but C is holy. It's
Nah,
yeah, you know what I mean.
bro. There's holy C and there's C,
Yeah.
man. That's a difference.
But I think it's so great. I made myself, and the enemy like he looks up like that. It's so good. The
Yeah.
C++ with this gravestone.
Wait,
PHP
where's
hanging
Odin?
itself.
Where's Odin?
Yeah, Odin has a shit logo to put in. That's why I didn't have it.
Ah,
Zig watching in the back. I think
yes.
it's so great.
I like the C++.
Yeah.
But there's need to
Yeah.
be a little bit of. Is it PHP?
Yeah.
Oh my days! Has it hanged itself in the back?
Yeah. Yeah.
Oh my days! Oh my god!
I think it's such a fun wallpaper.
I think you could still squeeze in a little bit of Odin there.
Yeah, but if you look at the logo of Odin,
Isn't that just text?
yeah, it's like kind of. That's why I didn't use it here.
But the
right?
assembly is also just text. What are you on about?
But it's like different texts.
PHP is also text. Come on, man. Now you're just
But
making
you
yourself.
see what I mean? Like,
No, but you know what you could do. You know what you could do.
make it as a rectangle, maybe. Not,
No,
yeah.
no. You could put it like a reflection in the water. You know, you make it like kind of wavy, like with ripples.
I could make
somewhere.
it, yeah.
That could work. Like just vibing somewhere there.
Yeah.
Not ripples, but what's it called? You know, when you if it were reflected on.
Like I did it here. Like I did it here with C.
Yeah, there. You can put it there.
I can put it somewhere in the background.
Yeah.
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 However, there's the Zig logo on his arm
Oh shit!
as he's
Yeah.
converting to C.
Come on. Oh no! I think both are still really good, C and Sig.
Yeah, yes, same.
Yeah.
I just want to make a very cliche
Yeah.
wallpaper.
And also, Odin haven't tried, but it looks really cool based on the.
I looked at Odin and it's I really feel it's really nice. So
Yeah. Like and the way how Webby have explained it to me, I'm like, wow. But Rust, I'm reading Rust right now, and I feel like it's way too much for accomplishing something. I'm like, what?
I don't know, like I don't have enough experience to.
Yeah, okay, I haven't programmed it to be fair. The problem with Odin is just that it's not trying to do anything special. It's not trying to be special. Let's see, what does this estimate surface edge interaction do? It takes a corner, and then another corner, and then it does a D, and it takes the sign distance field that it was supposed to be, I think, that thing. That's crazy.
Well, casts are crazy. I didn't know you could say corner 1 as U size. What?
Corner 1 is what? Oh? Wait, sorry, Swedish.
As U size.
As U size. Well, it's just casting.
Yeah, but it's weird, I mean.
Yeah, well, we do at as and then the type and then the
Yeah. Yeah, see, we don't do casting. No, just
see, we don't fuck that shit. What am I? Okay, I don't know. Like, I don't know if I like this one. Okay, I guess now when I read it, I think it actually kind of makes sense to read it like this, rather than the at as type thingy. I think this is actually a little bit cleaner, but still a bit weird. It's just a modern version of C. It doesn't try to change anything. Isn't that also like C3? Isn't that also kind of just a modern version of C? Or
yeah.
I would like to eat chips now. Oh, I could go for some chips. Okay.
No, I'm on a streak of not eating like sweets.
I mean, Sig is just crazy. Sig is turning dictator. Yeah. Andrew Kelly, man. Yeah. I'm not gonna. I still like it. Let's see. But what are we? If two cube corners point between them where the SDF is 0, this might not exist. So it takes in a corner. This is basically the method I tried to explain earlier on, and then it takes the value 1 divided by value 1 minus value 2, interp 1 minus interp 1, and then interp 2 multiple cube corner vectors. What the fuck are these things? Okay, this one is a bit of a headache trying to understand what the fuck is going on, because it does it twice, and it's just that's it. But where does it return the value? It just does this thing and it's like, okay, I'm good. Is this automatically a return? What the fuck? Okay, I guess it's in the register, you know, because you still have to put them somewhere, but Jesus, that's cursed if that's a return. If this is a return, oh my god. I mean, if we
I
did...
think it is very probable that it returns. Yeah. I think it is. I think I might have read also that like in Rust it returns automatically.
Because it kind of could make sense, you know, in the sense of how the stack works, you know.
Yeah, but no, it won't put it like. Yeah. Okay, I guess.
Depending on the like API, whose responsibility is to store the values.
By the way, that's also the thing I saw in Odin. I think you can name the variable you want to return and then just set it in the function and it returns it automatically. But that's just I don't know if it's nice or
okay. I mean, if we did a challenge with switching programming language for a period, I would for sure try it. Do like a game jam issues.
In what?
In Zig. I think if we were to do a game jam, we probably would all just C, because C is still like somewhat acceptable by everyone. Like there's no one who's strongly against it, I feel. Everyone
is anyone strongly against like Rust, Odin, or Zig? I don't know.
No, but I think it's a little bit like everybody knows a little bit of C. If we were to do a different programming language, it would be a little bit of different syntax to understand for most of us. We just compare the results. We would do a game jam against each other, and then we would have to like see how good somebody performs with Raylib or something.
Well, the thing is, it's like I don't know. I think it's way easier to understand C than like if you're, for example, doing Rust.
Yeah, definitely, 100%. Rust is rough, but yeah. Am I just gonna like take this for granted and be like, yeah, surely this works, right? Like just go with it. Like, yeah. What the fuck is this thing? I think this is a float point, right? C is also rough because you have to link it. But I think every language, well, yeah, you have to link it.
Like I may be a little biased, but I swear I think like coming back to it. Okay, I may be a little too biased, but like in my opinion, C is like a very easy build system to get right for your platform, but it's hard to get right for every platform.
It's wait. I'm not
like bro, not gonna lie, I think Python is so cooked in the building thing because there's like 10 different ways.
Let's not talk about C++. Corner. Okay, they call them corn. Wait, what? Corner 1, corner 2. I'm so confused because isn't that just edge? Cube edges, but they call them corners. Okay, I guess when you take one of those, you get a corner. Yeah, that's true. But then you just pass in the corner. You don't pass the value of that corner. You just pass the corner. And then somehow in here you're... Okay. That's so weird. So we do corner 1 plus corner... 2 basically. Or that's not what we do. We actually take. What are these corners coming in? Okay, we're not. Okay, they're coming later. Okay, thank God. I was like, this doesn't make sense. Where'd they go? It's supposed to be the value one. Value 1 is the D1 over D1 minus D2. And I'm putting them in the sum. Great. And then there's the interp 2, which will be 1.0 minus interp 1. And then the sum, which will be equal to interp 2. And then multiplied by cube corner vectors. That's funny. Cube corner vectors. They're like, what does that even mean, cube corner vectors? Just the what?
Yeah, my thinking just problem is so fire. Like, it just depends how good you are and you can create basically anything. Problem is, being good is hard.
But isn't this just the same? This is the same thing. Why would
Why
I
do
do
you still
this?
have the cube edges? Why do you represent the cube edges in binary?
I'm just following whatever the fuck this thing is doing. I could probably have put 0 and then 1 here, and then 0 and 2, and 0 and 3, and 1 and 4. But they chose that, so I'm doing that too now. But these are literally just cube corners. Taking in the, was it edge 0? It's literally the same thing, they just have it named differently. I don't get it. So then passing in corner 1, so that's my edge 0, and then plus interp 1 multiplied by cube corners taking edge 1. That's it. And then once
I
we're
really
done,
want to create a PS4 game, to be honest.
you want a PS4 game?
Yeah, I'm reading a book right now. You know the one book about game engines that you told me about? I'm reading
Game
that one.
engine architecture, yeah?
Yeah. And like he's talking about like PlayStation controllers and stuff. and I
Yeah.
think
Did
it
you
was
get the
fire.
4th or the 5th edition just came out, I think.
Yeah, and I have
The
third
third.
one.
Ah.
Yeah.
Yeah, but what he was talking about
Weak.
controllers?
Yeah.
Fish. Fish.
Yo, what's up, Döner?
Yo, what's up, doing Wordle? Wait, what else happened here? Webby said something. I will probably see it's so rough because you have to link it. I will probably spend 2 to 3 days with it. The thing is, if I were to do the C language, I don't know if I could stay within just the C lang. I think I'd like to decur C++ C style. Yeah. But yeah, you said something about controllers in the book. What did you say?
Yeah, he's talking about controllers right now. I feel it's
Mm.
just fucking fire to have this vibrator. Okay, that sounds wrong now, but
Yeah, I was like, whoa. Hey, yeah, my god, damn.
Oh no, and
Okay.
Lucas, you need to imagine I'm doing a system update since the last 3 hours, and my average download speed is like 200 kilobytes a second. I don't know why. And Daniel Wörtel said it would be faster if you walk here, download it here, and
Yeah.
then walk back.
Yeah, probably would. Let me see. This is gonna be sum divided by count. And then it goes back up to here. Then they push that as positions and then normal and then return through. I still don't see how this... Oh yeah, and then we're here. So this is my vertex that I would push. Okay. So we can actually take this down, 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 down here. And then we'll do here at panic. We're not supposed to use it for the server yet. Not implemented for server yet. We'll just do this. Lazy. And then now we got the centroid, which is supposed to be the actual position. Is that right? So then I will just append. I will just do the wrong thing here, but that's okay. Because now we get to the point where this should be fine. Surface, but I will still just do one. Am I not supposed to do? I'm not supposed to do 4, I thought, but let's see. We'll just say this one is equal to the centroid. And this one centroid as well. Color could be the same. Or centroid and centroid. Now, does that build? It does. Okay. Let's respawn the planet and let's see how bad it looks. It looks the same. Probably does. Let's see. Take a snapshot. Yeah, exactly the same. I don't get it. What's the difference? It's the same thing. It's supposed to... Yeah. I'm supposed to get all of the points, huh? This is stupid. I guess we made it look fancy now, but it's still doing the same. Oh wait, did I append? Yeah, I did do the output positions. Wait a minute. But this one is using the stride. Hold on. This is not the same thing. Wait. Null vertex. Straight to index. But how does it surface points, surface strides? Still confused. How does this connect with anything? Estimate surface. Where do we call this from? It's just called. It's not. How do we combine this to actually make something? Don't care about the gradient. Make all quads. Okay, this I could care about because this maybe make quads. Yeah, okay, so estimate surface, there we do it. So then it does it here separately after it has done all of the... Okay. Interesting. I'm actually like hungry as fuck. We're gonna still push through a little bit and then... Just looking at the phone. Hungry. What do we have the time? It's like, yeah. Check the time twice. How tired am I? How the fuck tired am I? Okay, make all quad. For every edge that crosses the... What is that sound? Is it from you, T-Chef? I heard like a spinning sound. Okay.
Yeah, it's probably my how's it called? Thing that puts air moving, so it's colder.
It puts air moving.
Yes.
It's called a Roomba.
What?
For
A
every edge.
fan, exactly, a fan.
Ah, fan.
Yeah.
You have a fan, damn. For every edge that
Bro.
crosses.
If you would know how hot it is here.
If you knew how hot it is here, it's like raining. For every edge that crosses the iso surface, make a quad between the centers of the 4 cubes touching that surface. Like, what the fuck is that supposed to mean? You have like a... can I put this one down? Okay, so for every edge that crosses the iso surface, so you have like blah blah blah, that thing. And for every edge... Okay, so we have like these edges. That crosses that iso surface, makes a quad between the centers. So there's a center, I assume these are the centers, right? Of the 4 cubes that... because there are like actually there, and then it will make a quad there. Okay. That touches that surface. The centers are actually the vertex position found earlier. Yes. Also make sure that's the centroids that I created here, and then I pushed them as vertices here. Those are the positions created earlier. Also make sure the triangles are facing the right way. See the comments on maybe make quad to help with understanding the indexing. Maybe I should do that. Let's make it somewhat right first. We can just ignore face calling, and it will be fine. For now, at least, just to see if it works. Then we can worry about the other one. Let's see. Make all quads. We do call it here with a min max also, and the min and max was also passed into here. Oh, it's just the shape size. Okay, I see now. So that's my radius basically for my planet. Yes. Make all quads. So shape linearize x, y, z strides. Okay, so they do not use the actual just a vector. They make it like this, but that's fine. I do my vectors. And for
I can't, bro.
is Cheesecake doing something funny again?
No, not words in voice chat. No.
Or is Doomber still doing something funny now? This guy.
Madonna, yeah.
What is this? Yeah, kind of same for us. I think yesterday it was like 37 only. I know neighbor. What is I know neighbor supposed
Yeah,
to
you
be?
don't get but we're neighbors in lands. He's in Netherlands and I'm in Germany. We're next to each other. And we were talking about. Wait, you gotta read this at the top, folks. Go a little bit more up. Oh, das ist jetzt immer. Yeah, okay, yeah. Right, not that much. Yeah, you can read from here. Yeah.
From the okay?
From them.
From
From
them.
my dad,
Responsible with money. What's that? I never heard of her. A fan? Well, makes me think of a colleague yesterday. For a context, it was very warm and the manager was using one of those hand blower to cool himself down. Okay, another colleague, she walked up to the manager and says, if I get tired, I can blow you, Lama. How warm is it for you? That's crazy. At the moment or yesterday, I know, and she was enjoying his shocked expression so much. 40. Yeah, kind of same for us. Though I think yesterday it was like 37 only. I know neighbor. Okay, I felt like the conversation you had, there's like, you had like two ongoing at the same time. I have no idea what the fuck you're talking about now. Chats on stream, yes.
You need to be multi-thread for that. Bro, I swear he said, yeah, bro.
Immediately with the multi-threaded Toonword lost this multi-threading.
Yeah.
Oh my god. That's insane. Holy shit.
Okay, bro. You can't listen. Okay, no.
Okay, come on now. Now let me try to understand this thing. What the fuck? So they do a XYZ strides as U size. Yeah, that makes sense. Sure, why not? You have like 110, 100, so you have 111. Sure, something like that. And then you do 4 XYZ reference P stride, which comes from where is this P stride? Remove. But Peace right, that's just a thing that they create here? Or what the fuck? Where is it coming from? Yeah, okay, I guess so. Sure, why not? Or is it from... I really don't know. I'm gonna assume that it's just something that they create. They're on the spot. They create something called peace stride. Sure, we go with that. I don't know. In output, wait, they take it from output. Oh, okay, maybe that's no. What? Surface points iterator zip out surf. Okay, so they get the x, y, z output surface points. And surface points, I guess, are my vertices, aren't they? Let's see, where do they do the push? They get here centroid, and no, that's positions. What are surface points? Surface points are these things where they just push every point that has a point. Okay. So there's surface points. Okay. Fuck. But shouldn't I do, maybe I could do a hash map, I guess, with that. So you push the point, and then you have a reference kind of like actual position, which is the centroid. I will do them separately of right now, I think. Will I?
Wait. Holy pokes.
No, I cannot. Why? Okay, let's read a little bit more. So that's their actual like position. And then what do they do next? They get the actual position. They have a stride associated with it apparently. P stride. Is that actually it? They do a... But how? Because I just see surface points being pure positions, not anything to do with strides. Unless if there is a stride. Did I see it? Did I see it? Did I not see surface point, surface? Okay, wait, no. They do surface strides. So they have both the stride and the surface points. So they have a point that refers to the... Which are the same things, because they should accumulate to be the exact same thing, should it not? Stride is the point, and it's not... Is it passed by reference into this thing? No, it's not. So it's not even manipulated. So the stride is just the same thing that they push. They push this thing and then they push the stride, which both mean the same thing. Just one is one-dimensional, and the other one is a vector representing the same thing that you could calculate using this. Interesting. Okay. I think that's how it is. Make all quotes. Let's continue then. We don't need this. And then P stride, they just get that. Evil max plane config, not feature evil max. Yeah, let's not think about that. What is this? This is like a... This called here somewhere. I don't know. Do edges parallel with the x-axis. So, but how do you figure if something is like... This is probably just making... Oh, wait, this is not making stuff that are... But how do we get the slopey stuff? We'll get to it. Let's see. Okay, so... Do we just parallel with the x-axis? So you get the x-axis, you get if y, where did we get... Okay, what the fuck? Where's the y coming from? I guess you can just take the y from here somehow, maybe? I don't know. It's not equal to min y, which comes from somewhere. Oh, it comes from... Yeah, okay, you can just do that. And z is not equal to min z, and evil max plane... or evaluate max plane. Do it parallel with the x-axis. So you have the x like this. So we are not at the minimum y, and we are not at the minimum z. So these borders over here, and evil max plane. So What? Do more use, yippee, yay! And then, and Max Plane. Oh no, spamming lizard technology. Or, what is x is not equal to max x minus 1. So we just don't want to be, we don't want to be here, we don't want to be here, and we don't, but we can't be anywhere else. They only have individual cooldowns. Oh shit. I should put them on shared cooldowns or something like that. Maybe make quad then. Interesting. I don't know if you can. How dare you? I will remove all of them except for Yippee, and they all will have one cooldown. SDF output strides to index. Let's see. Output stride to index. And then output positions. And then P stride X, Y, Z strides. What the fuck are these X, Y, Z strides now? Ah, they are coming from somewhere. Ah, there they are. The axis. So the 0, 1, 2, 3, that's fire. And then they go through for loop. But do we even the for loop? Oh, so what does it? The fuck? Looks like why? What are you saying? Sad yippee. Never knew Mulberry was kinda cooked. Who's Mulberry? It looks wise. What looks wise? Oh, that's Mulberry. I still don't know who Mulberry is. Haven't seen that person before. Pretty well known Minecraft modder. Ah, yeah, I don't really do Minecraft anymore. So what would I know? Okay. Don't worry, Don't worry, you don't know shit. Oh, thank you. The guy straight up just went, you don't worry, you don't know shit anyway.
You don't know game.
You don't know shit anyways. Don't forget the heart. Oh yeah, the heart. Yeah, you put a nice heart there. He's very kind. But yeah, I guess we do not append the vertices or indices yet. We will just append the verts, and with that, I need to know now kind of, I'm thinking I will probably do, so we'll do all of this, and then once we have done all of the iterations, which is down here, what we can do now is a for loop for all of the axes, right? So oh wait, do I need a for the axes? Am I dumb or... Well, I guess because I'm thinking I'm pretty dumb, you know? And we could probably just... But no, that wouldn't make sense. No, that would be dumb as... no. We want a for loop all of the positions. It's not like the vertex positions, it is the actual positions that we store. So let's do that as well. So we have the vertices, and then we'll have the positions. Until I figure out why this is a bad idea, I will do this. And that will be an nset vec3 of f30 i32. These are whole integers. u32 probably we want. No, we actually have negative values. So a hash map is gonna be the case probably to be used. And it's one of the cons of having a girlfriend. It makes you not know she got to go. Alright, take care, Cartoon Wordle. What the fuck, man? You just gave me new spittings like mad facts.
Yeah.
Based by. And when we append a vertex, we know which position we are working on. So we can also do a try positions append GPA, and what we'll append is now the item, the position that we're actually relative working with, and that is, what is that? Is that just the XY set? Oh, it is the XY set. XY set. Now that will probably not work. It should complain. It doesn't. That's freaking weird. That's like almost scary that doesn't. Anyways. So now we got the positions stored in here. Okay, I think the LSP is cooked. That's why it doesn't complain. Something is wrong here. We're gonna have a lot of problems with actually trying to run this thing. I wonder if it runs at all. Let me try something. What if I just run a normal instance of this thing? What will happen? Yeah, I assume so. Start, yeah. It has never worked. Why does it compile then? I hate this thing. It's just lying to me. It likes to lie. For no apparent reason. Let me just do this. And now open it again. What's wrong with this then? JSON LSP ZLS. I hate it. I hate it. I can't get my LSP working at all. It's just cooked. I get no. There's nothing that tells me that start is not fine, but it is not fine. Even though it says it's fine, but it's not. Expected type F32 found I32. So we have to do a int. No, float from it. So actually anything that I ever run here never worked actually because it didn't tell me shit. Expected type after found I32. What would it be? Maybe this one should already be an F32. Expected F3 found I32. Let's change it all to we'll just cast it to an integer once I'm done. Because I'm using F for F32 for everything else except for the position at least. Expected an integer or vector found F32. Yes, so we're not gonna incast this. We're just gonna say for at max. And then found U32. Well, this one has to be a expected, so I can do at float from int. But it should have an own result type now because it's getting in. What the fuck? Why do I divide it by? Okay, we'll do this so I don't have to do casting. Just do if size is less than 4, then it's equal to 4. Else at float from int size. And then pointer capture of non-pointer type. Fucking hell. Why can't it just tell me it in here? Like, why? Ugh. Shit. Pointer capture of non-pointer type. Because I kind of want those. If I can't use that, then I will have to do a... Well, I can do that. I can get rid of doing this. And we can instead tell it corners I. Now we get LSB. Wow, that's great. But then I would have to take the reference again here. So I would pass that. Use a unclear identifier, corners. Mixed scalar vector operand F32. Right, this actually just provides me with a what? Squat and farted and left the room, bruh. That's great. Oh my gosh, it's fine there. Look at this. Sure, that's pretty. That's yeah. That have to make you has to make your day, man. That's crazy, man. Well, actually, what do I want here now? Because I kind of want to work with. I get like this thing, and then I want to know. Well, I guess I need to do this then. X, Y, Z. Now cannot assign to constant. What? Damn. Expected vector found pointer. Yeah, but I have to take pointer. I'm gonna have to manipulate those. Yeah, am I wrong in that? Am I wrong in passing pointer here? Because I think I need to pass a pointer there. Yes, drop the bonds by value, not a point. No, passing pointer is for structure when I need to mutate. I think. Do I need any longer? That's actually a good question. Let's see. Ah, no, I don't need to mutate any longer. Okay. I thought I was gonna mutate it, but no, then it's fine. Then I can do that. Because if I don't, yeah. Radius, expected integer type found F32. Yeah, we don't need to do that. I don't get any LSB until I run. It's so freaking annoying every time. Expect type vector comp time. What's that? Line 48. Ah, that's flat. And I cannot get it until I run. Wait, let me do a Zig build. Dash watch. I don't even have to do this shit. Just put it here. And that's line 52. So in here, yeah, I assume so. Mix scalar and vector operand. Comp time loads. What? I will get a nset vec here. Right. I need to know the dist. Do I have something very wrong here? Wait, dist. Yeah, that should only corner distance should only be 8 of F32, not whatever the fuck I'm doing. Okay, that's funny. And once we have done that... Oh no, because I'm actually using... No, they are using distance. I'm using still vectors. Yeah, that's right. Okay, good. I actually need to do an end set here. Vec3, vec length passing in this thing. That's what I need to do. Okay, I was like, what the fuck? But now remember, no, I'm not using the stride stuff, so I cannot. I do it slightly different. And then expected type after you found vector at 54. Maybe if I just do this already over here. Wrong button. And now I get LSP, that's great. Mixed scalar vector operand after the a. Okay, let's see. And the sum. Interp cube corner edge. Oh, but I do want to scale it by that, right? I assume that the corner edge is an actual position, so yeah. Sum is also a position, isn't it? Yeah, so we do want a vector here. Now we want to do a scale. And sets vec scale, taking the vector first. God. Not that. Let me type J. So the vector first, and then the scale will be... Is it interp 2 or interp 1? Interp 2 first, okay. And I will do plus and set scale, scale. And I will do this one with the interp so. Where the fuck did I put the thing? Right there. Here. And then centroid, mixed scalar vector operand. Yeah, so now I want to do this. I need to divide. Do I have such a function in it? No. And set vector distance square dot. Well, I can still scale it by the inverse. It'll be the same. So scale sum by 1 over count. That's the same thing. If I have 2, if I divide by 2, then I have it. If I divide by 1 over, if I multiply by 1 over 2, yeah, it's the same thing. Yeah. And then exploit that after found U32. I know this is a float, but that's a simple one. Just add float from int. And then it has to know what kind of. Well, count could just be a float. It's not that crazy. Expect I to found you F32 positions. And that's basically this thing. That paste. And I forgot the parentheses. Spirit type found I32. Float from int, but it's the float out the other way around. Back, okay. Int from float. Should be a whole number anyways, but maybe we want to truncate. Let's see. Now it actually built, but I don't think it works. Where's the actual application? It says that it's running, but I don't see it anywhere. Wait, launch options. Launch it. I cannot move. I cannot move it. Let me just relaunch that. What the fuck happened? I cannot move on a single one of these. What? Do I have a print still in here? No, I do not. But I do not move. That's not fire. Not fire at all. But it renders some things. I mean, it has to complete this whole thing. Why can't I get the right parentheses there? What happened? It doesn't say completed once. Is it stuck in an infinite loop? It has to be. was, and then it's evaluating. It just doesn't do anything. Don't get a single print. Like it's stuck somewhere in a forever loop somewhere else. Like what the fuck? The server is sending packets, right? Oh, I'm so dumb. I'm so freaking dumb. No, wait, that I should still see, but well, it went through. Yeah. But only to, it went from -4 to 4. I think we need a +1 maybe. Hmm. Okay, but that's fine. We haven't done the indices yet, so that's why I can't render. Then it's fine. Let's see. Let's next here. So now we're supposed to. Here we are. So for every point, self. No, for positions, items, we'll call it position. Funny. I don't think position makes sense. And then if we could do that, const y or x is equal to position 0. Let's make it simple for us to use. Y 1 z. And then if y, well, from us this will be, is not radius, or is it, what do I do here? It's like actually like I should probably have min x min star as well. Or it's just clamp size. Can remove it's So if it's not minus clamp size, and set is not minus clamp size, and eval max, well, I do not have that. X is not clamp size. That's fine. Let's see how bad this goes. Maybe make quad. Well, this could be a function because this is apparently called multiple times. So yeah, this makes sense.
What's up?
What's up, T-Chef? I'm hungry.
Unless the guy joined.
I'm actually hungry as fuck, bro. I want to make something at least that kind of looks at the right direction for I eat though, because fuck, man. Maybe make quad. What is it supposed to take in? Positions and P. Let's see, what does it do? It takes in the stride to index. Don't know what that is. It takes in the positions. I can just take the positions. Then takes the P stride. I can just take positions. Then take the P stride, XY start stride. I can just take the positions. And then output indices. Okay. I will just do it first manual for this first one because I have all of the things that I need here right now. So let's see. First of all, it needs the D1 and D2 for the 0.1 and 0.2, which are U sizes. Oh shit. And those U sizes are, okay, it's the sign distance fields for, oh my god, I do not store that information. I need to store it right now. That's the information that you get here, D1 and D2. So we want to store it for this position. We want to store the D's. Yeah, okay. The D, we don't want to store the actual, like, oh, because this is for each cube edge, which we're basically just recomputing now. No, wait. What? We only have done the 2-dimensional ones, not 3-dimensionals. Position 1, position 2. Get SDF unchecked. Oh, so no, it's not a value yet. Or oh no, we check if it's. Why would we check? Oh my. Yeah. Okay, no, this is fine. We'll just check that if it's inside. Why would we do that? I thought we already had done this work. Negative phase. Ah, we just, okay. Let's do that then. Well, can I call it dxdy? Do that for now. And then, is that all we need the d's for? That we just check if it's a negative phase? Seems like it. Okay, well then we can just immediately do that check. So the phase const the pool, and we'll see if it's a -1 if both of those are negative. And that's basically checking if it's inside for me is solid. So if it's solid, yeah, it's solid, say B. But then I want the position, so it's for position The radius is radius. Let's see. So if both so if this one is true, that was false. No face otherwise. Probably could do some block stuff here, but so if this one is true, the other one is false. Or if this one is false, another one is true. So then it's false if this one is, oh my god. If I think it's smarter just to do this. I don't know, probably it's a fancy way to do it. Const P1 negative. Then I'm gonna do it like this now. Then we're gonna do P2 and then if P1 and P2 not P2 or not P1 and P2. Else, fuck, this is wrong. Just wrong, logic is wrong. Okay, I'm still gonna make it easier then. Fuck. I know there's a way to make this cleaner, but I don't know how. You can actually do this. No. If P1 and not P2 negative was it true false else if not P1 and P2 negative true else return. But this returns the whole function. Ha! Get to continue is the thing I'm gonna do. Now we just need to get P2. What is P2? P2 is the position with stride x, y, what the fuck? Oh, so it's the axis. So we want to get another axis in the y. Okay. So then it's dx dy plus 1 dz. That's what. And then with that, we now know the phase direction. Triangle points.
Okay, Lucas, so go now and train.
Alright.
How's your calisthenics training going?
Oh, it's alright, you know. I'm progressing. It's getting good. I mean, I can almost do a normal pistol squat now without like support.
Oh,
Yeah. Crazy.
That's actually fire.
Yeah. All right. Take
All
care.
right. Take care. See ya.
Bye bye. The triangle points viewed face front look like this. Vertex 1, vertex 2, vertex 3, vertex 4. Vertex 1, stride to index, P1. Axis B stride, axis C stride, axis B stride plus minus axis C stride. And then stride to index. And then positions. Yeah, don't do that. I think I just... But that's a dumb... Okay, well, yeah, we're getting parallel positions, so... Yeah, this is gonna go out of bounds. I have no way of finding that position. You're joking, this is dumb as fuck. Okay. Well, I could also just say position yada yada yada. Because I guess now I understand what this config evil max plane, but I'm not really quite sure. Evil max plane. But yeah, okay, so we would get every single one of those and then split the quad along the shortest axis rather than the longer one. What? Quad if position distance squared, position if negative, else. And then indices extend from slice quad. But then you would have to have the index. Yeah. So we just need the indices now for every single one of these points. I need to be able to map them for... Huh. Mapping them somehow. I need to be able to map them somehow to be able to get every single vertex that is associated. I need that vertex index somehow. Straight to index, yeah. And I do not store their indices in any kind of way, except I could do a hash map where I would just pass in the index what you want, and then it would provide you, or the position, and it will provide you with the index. Or I could just loop the positions until I find the damn index. What you working on? Hello, Luis Fitness 09. I'm working on getting net frame. What do you want to call a net frame? Surface net working. Surface nets, yeah, that's what they're called. It's just a better algorithm for marching cubes alternative. But it's yeah, I'm not that good with it. Yeah. Okay, I think I will probably just do a hash map. Probably would be good. Just to get it to work. I think I would do that. because I don't, well, necessarily I don't need it yet, so I could just do it, right? Let's see, post hash. I'm gonna call it post hash. It's a stupid name, but it's good enough to get it working. Hash map unmanaged. Hash map. Now I want an array. Array hash map unmanaged. There's no, okay, that's okay. And then, oh wait, auto. I forgot about it. Auto. Array hash map. Auto array hash map unmanaged. There, I don't. And then we're gonna provide the type. It's gonna be nset vec3 i32, and then you will get back a huge size, maybe index. We'll do u32 until it complains. Is there a dot empty also for existing? Great. Now with this thing, post hash, we can go in here when we actually create the positions, and we can also do a try. I'm not typing. Great. Try post hash put. We'll put that with the allocator, and then we want to provide the key and the value. You have cool accent. Where are you from? Thank you. I'm from Finland. My mother tongue is Swedish though. Where are you from? Post hash. Yeah, we'll go with that. And key value. So the key will be the position that we just. Fuck. Why am I making so? Well, it's okay. We can do it the most stupid way I know possible. Items, and we'll exit it. Oh wait, I could just do get last. Thank God. And because that's the latest one we just added, and then we will also know. Oh my God, this is so dumb. Probably there's a super smarter way than this. Nah. Len -1. Like so. Because now we can access any of the indices with that. So that means we can go back down here and we could. I'm just gonna do the top. Did I remove stuff? No, I'm here. Good. I've been to Finland, Helsinki, and the Northern Lights last year. I'm from America. Ah, okay, cool. Yeah, we have Northern Lights here. But Helsinki, yeah, I guess you can see it's from there as well. I'm actually, I used to live in Helsinki for 2 years, but I moved away from it. Then what we'll do now is that we should be able to. I do not travel much. No. You guys have nice saunas there. Yeah. We have really nice saunas. I love the sauna, man. It's the best. The best. It's really cool. Well, it's not really cool. It's really warm. But yeah, we would like to get every single vertex now that is. We want the vertex. Is vertex 1 like the top? We are assuming, are these X positions or what are these positions? The triangle points viewed face front look like this, but are these like, let's see, what does it say? With the parallel with the x-axis, so parallel with the x-axis, we are going like this, and then we don't want anything that is the minimum, and we don't want anything that is the minimum set. Minimum y and set. But set is here. So these ones, and then we just do these ones. So the this must be then we're going like down, like this. So this will be a negative y. So we do have position 1. Let me do. We could do it like that, but I'm not gonna do it like that. We already got position, which is position. So now we can just do vertex to, am I, no wait, we want the indices, that's why we have to do it. Vertex 1, yeah, const vertex 1 is equal to, and now what we'll do is the hash, position hash get, and what we can do is provide the position that we got, damn, and yeah, and we'll do it for all of them. 2, 3, and we'll do 4. And now with these ones, it will have to change because I think it's easier to do it like this, which we basically do already here. We'll yank that and we'll put it in here. And yank that, and then we'll select this. Damn it. Fuck, I'm going the wrong way. There, boom, bam, bam, boom. Okay, we'll be slightly different though, but America doesn't really have the science culture. Damn. Yeah, but I think it's kind of like when you live. Canada could have it, you know. You kind of have to live in a country where there's it's just sad, basically. Wait, we want a positive set, I assume here. Let's see how bad this is gonna turn out. Gonna crash the whole computer now. Not 12. And these are all optionals right now. They shouldn't be. And you guys have so many cool spots to swim and do nature stuff. Yeah. We do. Definitely, 100%. Okay, let's see. Because this is I think I'd rather not do that. I think it wouldn't even matter. This. Let's just do this same order always. Yeah, we'll do that. So push with the, we want the indices. Push or append slice, append many. CPA, GPA, and then we'll do many of them. So we'll have the, could I just do, we're gonna do V1, V4, V2, V1, V3, V4. Like that. And yeah, I mean, we have to still check that if any of these are bad, we'll just do a continue silently. I think that's fine. Or yeah, we'll do this. I'll go here, then we'll do an or else continue. So, and this will just do the x-axis if it works, that is. It failed. Expect a user to found U size. Yeah, okay, so we're gonna do a U size. And it's so cool how they allow topless tanning in Finland too. They don't do that in America? That's weird. I thought I should have found I-32. I-92. Wait, hold on. What? Yeah, expected F32 found. Okay, wait, this is actually, yeah, it is. This is a float, and I do this as. Would I benefit from. I wouldn't. Oh, come on. That's so annoying. I think I would do more of the checks. But then again, I have to do it all over here again. Damn, that's annoying. That's really annoying. Okay, wait, I will do it like this. So the Y, just make sure it's the Y. Yeah, it's the min Y. So we're gonna paste it there, and we're gonna change it to 1. And we're gonna do an at float cast, or at float from int. Please tell me it's fine with that, but it doesn't say that it's not type. Oh, fuck this. Okay, you know what? It's easier than to do this. I'm just gonna do that then, because that will just be such a problem. We're gonna do this, and then we're gonna yank that, and then we're gonna do a here, paste it, do this, and then what we're gonna do is we're gonna select that, go down, and then we're gonna call it float. These things, yeah, crazy. And then we're gonna, alright, these like, yeah, good. We're gonna do an F there, then an F there, and then we're gonna do another F over here, like so. Let's see, what does it say now? Expected F32 found out 32. Okay, but that's not problem. Did it build? No, it did build. It's illegal, huh? Or is that illegal? Topless. Like, if you're gonna take some sun. Wow. Oh yeah, and then I forgot. The thing why I did this. At float from int. Literally the only reason why I did it. And then I broke it. And then I did it worse. Great. It probably needs to know what the fuck just happened. Okay. I don't know what the fuck this was about. Like so. And then we'll go to the end. That. Then we'll go here and we'll tell it to an F32. And expected a type F32 found I32 solid. F32. You're joking. Okay, well then it's easier to do this. We'll take all the... Didn't go... Oh wait, it selected the wrong visual. Okay, it's... Okay. F. And then F. Except for this one shouldn't have this thing. And then what's the problem? Cannot consider it constant. Whoops. Classic. Server is just completely hot reloading all the time. Type does not support array initialization. Don't tell me it won't say. Should be able to do that. What the fuck? What? That was bullshit as fuck. What the fuck just happened there? Okay, let me try again. B and then I. Okay, now it's not bullshitting me. Okay, good. Boom. Type const does not support array initialization. What's this on about? I swear to God, I should be able to apply like that. Type const array does not support array. This is bullshit. That should work. Okay, I will do indices and many or n times. No. Slice. That should be completely valid to do. There's no fucking way that's bullshit. That's so freaking dumb. There's no way, yeah. Okay, why the hell can I not just do that? Because I find that should be fine. I probably forgot the syntax. And I got no LSP actually when I do this thing. It's bullshit. The problem is you want slice. Oh, I need a reference. Also, yeah, it does. But where's the damn LSP for real? I'm getting infuriated. LSP. Should just say I let it clean it up because it has all of the LSP in it already. It would know. Type U does not support array initialization, and it probably doesn't want the extra brackets that I just added. No, still problematic. Oh, U size. Expected to type utility found U size indices. Right. Okay. What for heaven's sake? Come on, let me just do my thing. U32, and then we can do an at int cast. Oh wait, that's not where I want to be. I want to be pam 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 pam. Yeah. It should know its result type. There's no. It must has no result type. It's right there. It's right here. You see that? That's the result type. You know that, right? It has to know it. It's right there. It's right there. It has to be joking. There's no way that it doesn't count as it knowing its result type. Ah, no, it doesn't know what the fuck this is. Ah, oh my god, that's great. Let's remove it then and put it at as paste. What? U32. And we do need this, and then oh wait, that was a bit too early. And we can remove that space and go to the end. And where did we go? And expect an integer or vector found U size optional. Right. I guess must know. So now I'm stuck between either I cannot get the damn optional, or I can't get the. Wait, this one just sucks. Wait, this one just is missing a parentheses. Ah, okay. Or? No, wait, it's not. Where is it? So I cannot do the int cast because of this. You're joking. Has to be joking. Oh my god. I cannot do it because this one will return a. Wait, can I? If I do it before. Oh, no. I got it. Like so. And then we'll go back. Remove that. Go to the end and put it there. Okay, now that should be fine. Expected after statement. What? Position get parentheses int cast parentheses or else continue, then add as we have an extra parentheses. And then we're back to the same problem that incast must know its result type. You're joking. So I'm stuck in a loop with that. Incast must know. Oh, that's fantastic. I'm going insane. I'm going mental right now. This is bullshit. I can't. Wait. There's no. Okay, wait. Is it another? Wait, no. It has to be because yes, like that. Incast must have no what? It's line 103. I might as well just I don't know. This is bullshit. It's lying to me. It's freaking lying to me. I can't. Because if I'm getting the position and I'm saying that if it's a null, just continue, else you should be able to get that it is something, and then I'm telling it to incast it to a U32, and then it has no result type, which I'm quite a clear telling it that's a U32. Like, I can't. I don't know, man. This is bullshit. Do I actually have to do an intermediary state? That's probably better. I'm just gonna do that. Fuck that. Yeah, like so. That's pretty good. Save that. It's fun as fuck. And then we'll just do like this. At incast. Boom. I'm not tired. I'm hungry. I'm hungry. I'm not tired. I wanna get this done. No. Whoa. You made the Ankh, not a boy. What? Okay. Now, let's see how bad this looks. I'm expecting on the x-axis something, but I'm not seeing shit, bro. I don't think a single one of those got generated. Let's take a look in here. Launch. Ah, you're joking. Everything just falls apart. That's so funny. Yes. Not at all. Yes. I think I will just stick to OpenGL. Oh, this is not even OpenGL, bro. This is just loading vertices. Like, it has nothing to do with what graphics API you use. You could do this in I don't know, Unreal, and it would pretty much be the same thing. Okay, I really hard time telling myself what the fuck is what. Let's see, mesh viewer. I don't see this thing at all. Ah, there, the positions are nah. This is probably the thing that I'm supposed to deal with, yeah. Yeah, this is probably my planet. Woo! That's fantastic. I mean, it did something at least. That's pretty good. Like, you got something here. It says errors, but that's just because I'm pissed, right? Why is it going to 3, 2, 1? Do I have some logic incorrect here? Wait, let me see. No, because set should be equal to start every time. And then set. And this one should always reset back. You get the table. Weird. But I mean, some vertices are definitely there, but they are just broken. Pen, slice. Like, the only thing I don't really care about the absolute positions once I'm done, right? I just return the vertices and the indices that I care about. And those are these things. The vertices that I create here. I don't care about this. I don't care about these. And then here I care about the indices. But yet I somehow just get, I don't know. They're not there. Put a comma there just to piss myself off a little bit more. I mean, I don't even think I'm close. Like, I kind of getting close to getting like the flat things working, but I still need to get the slopes basically. And I think this thing doesn't cover the slopes. So that's pretty fire. I'll get it. I mean, it's just the first day of trying to implement these things and reading about it, so it's not too bad, right? It's not too bad. I will, but I'm gonna go eat. Maybe back for another stream. There are very few of the 6 devs on YouTube that, what do you even do, by the way? I do game development using no engine. Like, I can, if I, like, many of the others do like neural networks or, game development is quite popular, actually, I have noticed. But if we go to spawner and we go to the top, no wait, we go here. And I change this back to the original planet. Well, it's quite small now. Let me quickly just go to the server and fix that. Start stage. Let's actually let it be something. So it will hot reload the server real quick with that. Did it hot reload already? That was fast. Okay, and then I can just, that should work with a, it took quite a small size. Let's do another one. Okay, that one's a bit bigger. But yeah, this is what I'm working on, and then you can spawn the boss like that. It summons. It's still, I'm working on improving the networking, or I'm gonna work on improving the network. But right now it's fine for what it does. Right? There's no. Where's it? There. Wait, a bit overpowered, but it's just for testing right now. And then you reactivate, and it teleports you to a new planet. But yeah, I'm trying to improve this planet generation using surface net. Yeah. I mean, what do you do for a living? Don't say I eat food. Oh, I'm a poor student. I think this will automatically just switch to a. If I press K. It didn't register it. What? I did. I didn't press it hard enough. Yeah, no, I don't have a Jube. I don't know what other SIG programmers do. They are mainly just like doing well, promoting SIG, I guess. I'm just doing it to, well, I guess learn more about programming. I don't think there is any. I don't know. Maybe. Well, I do know a few employed SIG programmers who have jobs but not working in SIG usually. You inspire me, by the way. I just resigned to do my masters. Yeah. No. I am in university second year right now. Gonna start my bachelor's, or right, doing my bachelor's this, what is it called? But yeah, whatever that is. I'm not very into it. I'm doing it because in Finland you get student aid for studying. So I spend all my time then just grinding my own stuff, trying to program and learn stuff. Everybody else kind of knows all of these terms. I'm like, I don't know. I'm on my third year. Yeah, my third year is about to start. That's all I know. Pretty much. No, I know we're gonna do some C programming. That's gonna be freaking fire. But yeah, I think I will go eat, end it here. And tomorrow we will continue. That's what we'll do. Upgrading the planet, and then we'll make the enemies a bit better. And then I think audio or maybe networking. I would like to tackle the networking, but some audio would be freaking fire. You look older than me, but seems you're younger, I guess, and way more. I'm 24. I'm turning 25 soon. So, yeah, I'm quite old. Well, quite old. Depends who you ask, right? Depends who you ask. But I'm getting to the more, yeah. I'm not a boomer yet, but I feel like a boomer a lot of times. Maybe more talented. I think we all have our own thing that we do. Yeah. Like, I'm reading books also, and there's one thing I recently read, which was about philosophy, kind of like the book is called How to Read a Book, and it's quite interesting. But because they're like yeah, it's good to read philosophy, but also it's better to make up your own mind. And kind of like I think about programming as well. It's better for you to discover your own kind of way of thinking and approaching things. Those are the best answers you can get. But also, I'm thinking like, but if you don't know much, you kind of need to find someone who has done more than you, who can explain things in a better way, so you can actually attach to something better. But when you get to your own kind of solution, it's really powerful. But yeah, I need to figure these net surfaces out still. Like, I'm freaking lost about them. Okay, but yeah, I need to end it here, or otherwise I will never end it. Thank you for watching today. How many are still watching? I wonder about doing a raid, perhaps, but you're not. You're like one over at Twitch. Well, thank you for watching. We'll end it here, and tomorrow we'll continue with this better planet. Getting it soon, right? All right. Bye bye. Take care.